Shall we get started? Okay. So good morning, everyone, or good evening to some of you. Welcome to Women in Data Science Istanbul 2022. We are very excited to host you today virtually, but we have a fantastic line of speakers today, accomplished and very inspiring women. Before we start, as we are with Istanbul ambassadors, we will briefly introduce ourselves to you. I am Özgür Taştan. I'm a faculty at Sabancı University, also a member of VERIM, the Center of Excellence in Data Analytics at Sabancı University. And Özge.
Hello everyone, I'm Özge Özmen. I'm founder of Data Science Turkey and also I'm data science instructor at BTK Academy. Nice to meet you all.
And hi everyone, I'm Aslıhan Demirkaya. I'm a research data scientist at WiDS Systems, which is located in Palo Alto. And I'm also affiliated with the University of Hartford and University of San Francisco. Let's start with a brief introduction. What is WiDS, Women in Data Science? It was first organized by Stanford University for the first time in 2015, and then it turned into a worldwide conference. WiDS has reached to more than 150 regional events in more than 60 countries and reaching 100,000 participants annually online and in person. WiDS Istanbul is one of the regional events, and it's an independent event. And as WiDS does, it aims to inspire, educate, and support women in data science. WiDS Worldwide Conference took place on March 7th, 2022, and I did attend this conference in person. There were incredible speakers. If you are interested in these speakers' videos, you can go to their website and watch them. Last year, we also organized WiDS Istanbul. And if this is a screenshot from last year, if you are curious about the event, you can scan this QR code and have an idea about this event. And after our event, Stanford wanted to share an article in April 2021, and this is a screenshot. Again, if you are curious, you can go to the website or just scan the QR code.
Okay, so this event is hosted by Sabancı University and VERIM. We have also several communication supporters. These are like student clubs that helped us to disseminate the existence of the event. Would you change, Aslan, to the next slide, please? Thank you. And before we get started, I'd like to thank to the volunteers of this event. This event was made possible by very inspiring and motivated set of young data scientists, which you will also see them at the end of the event. And could you go back to the next slide, please? And throughout today, I'd like to share you the handle of the social media account. So, and if you are tweeting or sharing a post, you can use this hashtag so that this will also help us to connect with each other. And to give a bird view overview of what's going to happen today, we will start by a keynote talk by Professor Berin Yanıkoğlu. And next we will have an invited talk titled Trends in AI. We will have a panel discussion. Last year, this was quite fun. These are data scientists, accomplished women in data science living in US, and they will share their experiences during this panel discussion. And next, we will have a networking event where these speakers at the panel discussion will be also in the rooms. The networking session will be in Turkish. So this event was actually in Turkish last year. This year we decided to do it in English to be able to connect with the other WiDS regional events and the WiDS Stanford University events, because they cannot follow what's going on during the day. But we'll see if if Turkish works better, maybe next year it will change. And we will have a brief lunch break. In the afternoon, we will have a session of invited talks, which is mostly researchy talks. And we will have a brief coffee break and a panel discussion at the end of the day of where the young data scientists speak. And Özge will be moderating this session. So before, I think we can take couple of minutes break while other attendees are joining, because we set the time for 9:15 for the talk. Shall we do that? Shall we wait for a couple of minutes so that people might come late for the talk? So, and then we can continue at 9:15.
Yeah, and then I'll share my screen in the meantime.
Okay, yeah, in the meantime, we can check, yeah. But I will be introducing you, so I like to introduce you on that slide. Yeah. Okay. Yeah, let's wait for a few minutes and then make it up.
Participants may be encouraged to use the chat screen.
Oh yeah, so I should note that. So not the chat, but the chat is inactivated for the participant. But we will be getting the Q&A box. The questions will be asked in the Q&A box. You can see it on the lower panel. So if you don't feel comfortable in English, you can ask your question in Turkish. We will be happy to translate. And most questions will be taken at the end of the talks, but if it is a pressing question and that prevents you understanding the talk, then you can, of course, ask it there. So I am delighted to introduce Professor Berin Yanıkoğlu. She's a faculty at Sabancı University, Computer Science and Engineering program, and she's the founding director of VERIM, the Center of Excellence in Data Analytics. She received a double major in computer science and mathematics from Boğaziçi University. She got her PhD in computer science from Dartmouth College. Professor Yanıkoğlu worked at Rockefeller University Xerox Imaging Systems, where Xerox was the company at the time, I think, and IBM Almaden Research Center before joining the Sabancı University in 2000. On a personal note, the very first programming course I took was offered by her, and it was very fun, which made me take other courses. She's one of the women pioneers in machine learning in research in Turkey. She's most known by her work in biometrics and in computer vision in general. She and her students won several awards, but she's so humble that she didn't share these in her bio, so I want to mention. She also likes to put her technical knowledge in use for societal good, which I witnessed as a colleague of her. And her recent work on COVID detection from CT scans is one of them. And I want to note that apart from her wit and intellect, as a colleague that works side by side by her, I am very inspired a lot by her positive and courageous attitude. So without further ado, the screen is yours, Berin Hocam. Please go ahead. You are muted.
Yeah. It will take a few seconds.
Yeah.
I'm going to be talking about deep learning for medical image understanding. This is also a new topic for me. I've been working on this for a few years. By the way, Öznur, thanks for inviting me. I'm honored to be here, and you have such a great program. So we'll enjoy today a lot. So AI in medicine, there's medical image understanding that I'm going to be mainly talking about, but AI in medicine covers a whole range of areas, research areas, anywhere from clinical diagnostic systems to dictation systems to helping doctors, augmented reality for supporting surgeries, and also, of course, more research in bioinformatics areas such as drug discovery and so on. But I'm going to be talking about medical image understanding, which is my research area as of late. What do we mean by medical image understanding? So, for instance, detecting or classifying any kind of abnormalities in radiology images. These are MRI, CTs, X-rays, and so on. We could do, for instance, detecting cancer in mammographies or detecting COVID-19 infection in chest CTs that we have worked on and so on. What else? I have been collaborating with doctors since the pandemic started, as Nur said, to try to sort of help the medical community a little bit with whatever we can do. Now we have started working on histopathology images. So this is during the brain operation, as I understand. Doctors are looking at this microscopic images to understand different structures in the cells and to classify different cells and so on. So a faster AI system would really help in that regard as well. So I'm going to be talking about these green lines as small projects that I'm involved right now with my students. Another one is tracking liver size from against CT images. This is something very tedious that doctors are doing that could be very well automated, and this is a really great use of AI in medicine. So if a patient comes in a couple of years, the doctors will be able to measure their liver size to see if there's any change that indicates to problems. Tracking skin moles, this is an application that could possibly be a mobile app or is that people can track their own skin moles to see any changes and so on. So this is what we are going to be talking about. It turns out that AI in medicine is not new. As I understand, Dr. Lodwick has started implementing such a system as early as 1950s. He's a well-known radiologist. There's clinical decision support systems since 1970s. Mycin is an example for that, like what kind of antibiotic to suggest to the doctors for the given ailments. And of course, many of you know the sudden leap in progress with deep learning within the field of machine learning in the last 10 years has brought significant leaps in almost all areas, including medical AI. During the pandemic, immediately within a month or so, the computer science community has provided solutions towards the detection and also understanding the severity of COVID-19. That was also very promising. And we have also been involved in such a work in Turkey. AI is now being used in many areas of medicine and healthcare, and we'll talk at the very end of the talk what is next. AI in radiology. So what is the problem? So radiologists may not be available. So if we are talking about remote locations or even in a big city such as Istanbul, timely access to a radiologist, like there are so many patients, there are few radiologists. So a radiologist seeing a particular patient may take some time, and that may be important. So this is one of the biggest needs. But then there's also the fact that the radiologist may miss some information on the image. This is mainly due to time shortage on the side of the doctor. But experiments have been done to show that doctors may not look at the whole image, again, due to time shortage or being distracted and so on. So may not look at the whole image, so may miss some important information. And also their expertise and experience vary. So if there's a particular rare issue that they haven't seen in their training, then they may also miss that. And doctors are saying that this is reported as high as 30% in missing or misinterpreting some finding. So these are all areas that AI could help. And sort of to say already what is in my mind as the contribution of AI in medical field is that it should work hand in hand with human doctors and to support them and not to replace them, as some fear. When we look at AI in radiology, so these are what it can cover. So it's cheap, it's available, it's fast, it won't get tired or bored. It is not foolproof, but it can assist physicians. And unlike a physician that requires years of training, radiology expert, it can actually access almost unlimited amounts of data, cases, in a very short amount of time. So it could be trained with those. I'm going to start talking about one of this project that we have done. This was in collaboration with Istanbul University Cerrahpaşa School of Medicine, and the project was started with the help of TÜBİTAK Ulusal Meteoroloji Enstitüsü. And this is about detecting the COVID-19 infection patterns in CT images. And we have developed this in a really brief time to sort of make it in time to the hospital to be used, and successfully installed it at Cerrahpaşa. I'm quite proud of this achievement because 3 of my PhD students worked on this problem all the way from alternative solutions to installing it. And this has been really a proud moment. So what is the motivation? The motivation was that at the beginning of the pandemic, the PCR tests were taking a long time, and there was also a lot of high negative results early in the stages of the disease. So what was happening is patients was coming to emergency room in Turkey. They could do that. They're showing symptoms, but their PCR test takes a long time, and they do get taken a CT, as this is available as commonly used in Turkey. But then radiologist takes a long time to see all of the patient's CTs. So the system is designed to sort of triage these CTs, seeing them and flagging what seems to have the COVID symptoms in the CTs. What do they look like? They sort of look like, they call them broken glass pattern, and there's some other patterns as well. But while the image of a healthy lung looks like mostly black in the CT scan, of course, there's also other parts, but you see this, what I call sort of like a smoke pattern in the lungs, shown in oranges here. So it is something that we could also see, and the computer certainly can see. So we know it's doable, but the problem is difficult. So what is a CT scan? In case you may be motivated to work in this area, CT scan is where they lie you down and they take axial slices of images. And so this whole thing is a volume, and it indicates it's sort of like image, but it's more complex. So air corresponds to -1000, lungs correspond to some range between -700 to -600 in this Hounsfield unit. And the more dense areas will have higher, like above 1000 HU values. So, and on the very right-hand side, you see the frontal view. This is for the liver project, and also underneath you see the axial view. And this shows the complexity of the problem, where you see the liver shape changing in each of the view. In each of the slices, it's a different shape because it comes in and goes out, some other organ is blocking it, and so on. The task is to detect the organ in each slice, in the COVID case, the lungs, and then detecting the COVID pattern in the lungs. But as I said, so this is about 500 slices, 250 to 500 slices per CT scan. And in this, so one row here is one patient, and in this CT volume, all of the slices look very, very different. And also between patients, it looks very different. And the number of slices varies depending on the, the resolution of the CT and also the person's height and so on. So this is a quite challenging problem. there's the COVID patterns on top. There's normal lung parenchyma in the middle. And then there's also quite complicating pneumonia or other non-COVID-19 patterns, which are also abnormal, but not to be confused with COVID-19. And this is the task that makes it harder. So some of the systems in the literature are working on just the top two classes, while we have also addressed the third one as well. And also this data is very large. So if you compare to a single image understanding problem, we are talking about 200 to 500 slices, variable number of slices, and this is a big data structure, a little different data structures and so on. This is one of the difficulty. And another difficulty is, of course, the weak label. So most of the data sets are just providing you with a CT scan, CT volume, and then just saying this shows COVID-19 symptoms or not. So imagine that you have the 500 slices and the doctor is just saying, this is COVID-19 positive, this is not. So imagine training an intern by not pointing to where the COVID pattern is, but by just saying this has it, this doesn't, this has it, this doesn't, and so on. So we have such a machine learning problem at hand. This is called the weak label. That is, we don't have the exact label, exact location, maybe not even a bounding box for the pattern indicating this. Another issue is in deep learning, we are dealing with, we have very powerful systems that has hundreds of millions of parameters. Now, actually, it's even billions. That need to be learned, but they need to be learned without overfitting to your training data. When you have so many variables, it's very easy to sort of latch on to some random events or idiosyncrasies in your training data and seemingly do a good job, but not have the required generalization power, generalization capability, not show generalization. So, for instance, it has been found in one of the CT systems in this work that the system could recognize COVID-19 patterns even when almost the whole image was blocked, was covered with black mask. How does it do it? It does it because the data set that it's been trained on shows some text or indication of one is showing COVID-19 symptoms, one is actually not, but they're coming from two different hospitals. And the system was actually learning which image comes from this hospital, and hence they are COVID-19, and the other comes from the other hospital, and so on. So this is the problem in deep learning, how to avoid overfitting. So one thing towards this is we do a lung region segmentation. That means given the whole CT volume, let's at least focus in the lung areas. So how do you do that? There's a great tool research called UNet, developed in 2015, which is basically a deep learning network in the shape of a U, which is the encoder on the left-hand side and then the decoder on the right-hand side. And the task is, given an image, single image, do some segmentation task. In this case, segment the lung regions, such as the green and orange on the right-hand side on the top. Okay, so if we have this, then what can we do? We obtain this lung mask, as we call it, and then if you superimpose or multiply with the original image, you are now just looking at the lung images. So we can actually eliminate all of the information that could fool the system or that the system can use to overfit. So now we are just going to look at focus on the lung regions, and this is working great. There's a lot of UNet data sets, UNet implementations, and also labeled sort of like lung regions and so on data sets. So you could use this to segment any medical image data set. And it works with about 98% success, which is really great. This is a qualitative result. We have just looked at some of them and also reported as such as well. Where does it fail? It fails on the edges mostly, shown in red blocks. So if there's also the infection on the very edges, sometimes it misses those, but overall it works quite well. One of the good aspects of this problem is because you have about 200 plus slices, even if you miss it on one image, one slice, you may catch the pattern, the COVID pattern on the next slice. So that's the good part. Okay, so how can we do this? How can we learn the COVID pattern given a CT volume? There's something called transfer learning. Most of you know, I'm sure, but there are systems that are pre-trained to do object recognition. And those models are available to us in Google Colab, Keras platform libraries, and so on. So these are done, but by often big companies such as Google and so on, and shared with the community. So I have the top system here that can recognize different kinds of objects. These are trained with very, very large data sets, and they can say, in this case, identify between car and a leopard and so on. But what happens is, in doing this learning, they have learned to extract good features. And now I'm going to be using this system, and I'll just change the very output layer, very last layer, and just repurpose this vision system, seeing system, to my purpose. So I'm going to say, you are able to see the objects, but how about let's repurpose you to see COVID-19 patterns. This is really necessary because we don't have so much data to constrain so many variables from scratch. So we are just going to use the model as is for the most part and just change a small set of parameters. Okay, so what kind of thing? So when they look at this learn network, if you see here, you will see that, let's say, the honeycomb at the very bottom, the honeycomb pattern. So if the network around towards the last layers can recognize a honeycomb pattern, it has learned that this is an important thing to identify to distinguish between different classes, or like this centric sort of patterns and so on. They could be used in all objects that shows similar sort of patterns in using this last layers of the mapping. So one of the approaches could then be take such a pre-trained network, take your images, your volume, and present them one by one to the system and sort of get a 1 or 0 COVID positive or COVID negative output at the end. And maybe you can sort of look at these and see if a certain number of them are saying are predicting COVID-19. So maybe we're going to say the patient has COVID-19. That's our baseline. And we can do this because these images are quite similar. The domain is similar to object classification, and it works like this. It's our baseline and does a pretty good job. But what it doesn't do is all of the domain knowledge that we have learned with working with the doctors. So the COVID-19 appears more in the bottom of the lungs, et cetera, et cetera. And maybe even just summary range. So we do not catch any temporal or sequence information when we treat this as independent images. So what we have done is we have done this network and taken the images learned by this, taken the features learned by this pre-trained network And on top of it, we use the recurrent neural network model that can capture this temporal dependencies. Just think of the idea as such. If my system somehow says there's COVID-19 where the lung shouldn't be, lung isn't, but somehow it says it by error, this recurrent network can correct it because it knows it is trained with sequence information. It knows that the COVID-19 isn't seen where lung isn't shown, for instance. So this brings something like a 2% point improvement over the baseline. So the baseline is doable, works fine, but you get improvement with a more complex model. And this is the state of art. One more would be to train this end to end, but we didn't have enough computational power for this. What other people have done and what could be done is to use so the green are our approaches. And what others have done, Lee et al. Here has used a Siamese, like a 256 branch Siamese network, where they give the slices one by one. The branches share the same weight, so it's actually the same network. And they can also combine the decision as such at the end of the network. That's a nice idea too, which is comparable to our approach. Another approach though is, can we, if this is a volume, like if we look at a video, you wouldn't want to process individual video frames one by one. You would like to process it as a video, as one whole thing. So another approach done by my other students, so the first one was done by Sarah Tito, now in University of Surrey, and this is done by Mehmet Can Yavuz, which is a PhD candidate, soon to graduate. So this is the 3D approach. It takes the whole volume and it does 3D convolutions and 3D and the adaptive global pooling operations to deal with the variable number of images. And so this is trained as one at one go and just gives the patient result at the end. We have modified an existing system and enriched the network, but also just a little thing, they were using interpolation to reduce the 500 slice images, for instance, to 250, just to reduce the size of the data and so on. What we have observed is when you do interpolation, you're actually really smoothing out this fine pattern. And when we remove this, we gained a lot of accuracy increase. You cannot remove it by just saying, I'm going to remove it. We don't have the computational power as well. So what we have done is we have skipped every other slice instead of averaging it out. And that way we could fit the data. But every other slice is more than enough to catch a COVID pattern as well. This network was also, there's no pre-trained network when you're talking about custom networks such as this. So what we have done is we have trained this network with other public data sets, such as MostMed. It just contains COVID or healthy images, fine, but it's still, when you pre-train a network with such a data set, the network is able to learn important patterns. It can learn to focus on lung areas and so on. And then we took this and we fine-tuned it with the Cerrahpaşa data set that we have collected to actually also distinguish between pneumonia-like patterns. Data augmentation is very important for deep learning. Data augmentation means you take your training set, which is often of medium size, like 10,000, 20,000, 100,000 images, but that's not really enough So we take those images and we augment the training set by showing slight variations of the image. On the right-hand side top, you see a skin mole, and you see it a little scaled up, a little shifted, we can do all kinds of different operations that should be suitable to your problem. You can apply a little rotation, a little translation, scaling. You can play with the colors a little bit if it won't matter for your problem. And that way you are teaching the network that this is still the same skin mold, this is still the same class, but don't just try to learn variations around it. So this is done to prevent overfitting. We have other methods such as dropout and so on, but data augmentation is one of the most important techniques. So the results in this system is in our Istanbul Cerrahpaşa data set, we have achieved around 90% when we combine, it's called ensemble averaging, the 2D and 3D system. This is quite good. And compared to the DeCoveNet was the 3D network that we started with, it's achieving 78%. When we have done interpolation, we had 82%. When we just skipped every other slide, it showed a 5% point improvement to 87%. And when we put the 2D and 3D together, as expected, as is often observed, the ensemble always improves, almost always. And we obtained a 90% accuracy. On the public MOSMET data set, which is just COVID versus healthy, we have obtained even higher, 93% results. There's a lot of sort of controversy about COVID-19 systems, and I ended up writing a blog about this. So there was a famous article saying that all of the COVID-19 systems are useless. Why? Because they have biases. But and this paper made a lot of impact to the system, negative impact to the whole research area. But actually, when you look deep down, it is not really fair to say that, because what they are doing is they are basically saying all deep learning networks, because we don't know what kind of features they are looking at, are biased. They have unclear bias, and then later on they go and classify unclear bias as biased. So this is a little unfair, but so we took a completely new data set and not used in training, not used in testing, not seen, etc. And we have tried our system on that data set and compared with some of the state-of-art systems on that, trained on that data set, and we obtained 90%. This is really a respectable result showing interoperability of the system. So it is lower than the best accuracy obtained for that data set, but we haven't trained at all with that data set. So this is quite good. When we look at the COVID-19 prediction distribution for COVID-19 patients, which is shown as orange, and for others, both pneumonia-like and the healthy patients, we see that the two groups are very well separated. In fact, we are using a 0.3 threshold right now. We were using it in the pandemic time to flag that someone is a score above 0.3 should be seen by a radiologist immediately. So you can also calibrate your system depending on how likely COVID-19 is at any period and bring it to the attention of the radiologist. This is our team. On the right-hand side, Istanbul Cerrahpaşa Radiology Department. On the left-hand side, my three PhD students. Two of them are graduated right now. Okay. Sorry. Okay. So just a couple other projects that I have since started with my undergraduate students mostly as graduation projects. This is a great chance for us to experience, get into new areas. So one is liver segmentation. As the doctor suggested, tracking a liver is really important to see the changes. So what this is aiming to do is, from the CT shown on the moving image, we would like to extract the liver volume. And the benefit is so that the physicians don't have to go and give the contour, which is very repetitive, it's tedious, time consuming, not repetitive, and it's highly varying among doctors and doesn't really give you a precise quantitative scores, has the same sort of challenges as the previous problem. We have used segmentation with the UNet that I showed you and obtained a DICE score of 94.5, which is really good. So here's some images. So this is the actual volume, measured volume is this, but you can measure the same volume, but it could be on the not overlapping with the actual liver, right? So we actually the DICE score indicates how much overlap, if you look on the right-hand side, how much overlap between the ground truth and the found area or volume. Okay, so the DICE score near 1 is really good, and we are quite close to that. And I think we are going to also put this system into use. Another project is prostate segmentation, a little more difficult. When you look at the prostate, this is an MR image. When you look at that, we first, in this problem, segment the prostate region, which is relatively easy. But then once segmented, we can concentrate on those images. Look, that this is quite complicated. We can concentrate on that region and then now try to do tumor detection, which is very, very difficult in this problem, but this is still ongoing work. The tumors do not, can appear in lighter, darker colors, can appear anywhere in the prostate and so on. But so far it's promising. Final work is with Dr. Erden Özer from Sidra Medicine. He moved there last year. So this is about histopathology images of brain tumor patients. So these are, we have 4 classes that we would like to distinguish between. So low grade, high grade glioma, and metastatic tumors. So they would like to understand this during the operation, as far as I understand, and an automated system would really help. And visually they are distinct enough, but there's some similarities and so on. And the whole slide is very big. We need to look patch-wise. This is one of the challenges. We don't have so much labels. We have some early results, but this is also another need in medical AI. And the skin mole classification was a couple of years ago with Sarah Tito and Cemre Zor and Joseph Kittler. This is something called ISIC 2019 challenge. The problem here, or the challenge, was that you want to classify skin lesions into one of 9 classes, so 8 quite common skin cancers. There are so many kinds, but then another one summarizing all of the other ones, saying we should be able to say this is none of them, this is other. This is a challenge still in machine learning. It's called an open set problem. In this case, we have used something called error correcting output codes. I'm not going to go into the details, but to be able to quantify how close to this 8 classes we are, and if not, to be able to say it's the other class. There was also a large class imbalance here, where the training set contained a lot of a common type of skin cancer and fewer of the other kind. So the accuracy is 60% in distinguishing between 8 or the other classes. And we were at some point second among the systems. There are a lot of Kaggle competitions like this. If you want to go in, start in this area, you can see how well you're doing. You can learn in the meantime. I suggest those. And finally, AI in medicine. I'm going to start wrapping up. So AI in medicine, where we are going. So we have sort of very, very briefly covered the history, but what is next? So some radiologists are saying, are we going to be not needed anymore? We are certainly far from that, but what we are going to do is what I expect, or what experts expect, is that it will not really replace doctors. It will work to assist doctors, but we still have to work on bias, explainability, accountability issues, which were covered in our last Miriam Summer School. These are the hot trends in hot research areas in machine learning, deep learning, and so on. For instance, your AI system can systematically give some negative results for a certain demographic. This is bias. It may not be explainable. It may say, no, operate, give this medicine, or do not operate, or etc., without giving you any explanation. That's an explainability issue. We can ask our doctors, why do you say that? We can discuss that. We can argue about it with different experts. But if the black box system, if it's a black box, you won't have an argument. You won't. So we do want explainability. But on the good side, in the future, they're going to be more reliable. So in many different systems, AI systems will increase in reliability. It will increase in explainability, and we are going to and they will be widely accessible, much more widely accessible than today. That's the end of my talk. So thanks for listening. And if there's any questions, I will take them.
Hocam, thank you very much. This was really interesting. I know the COVID work, but it has evolved a lot since I heard about it last time. It's very impressive. So for our attendees, you may ask your questions in the Q&A box. Feel free to write it in Turkish if you feel more comfortable. Someone is thanking you for the information. So in the meantime, while attendees are asking questions, maybe someone asked the question on the chat. Q&A will be much better, but it's okay. I'll read it from here. Do all studies give binary results, such as COVID or not, cancer or not, etc., or give interpretable results?
Actually, even our work, we obtain what we call probabilities for what is the probability or a score for the input. And I think most of them work like that. And then we just translate it into doctors as, in fact, we also provide it as a probability to the doctors as well. It is much more informative, as you say.
I am curious about one thing. So when you deploy this in real life in Cerrahpaşa, like, has there been cases, weird cases that also inform the system so that you could make improvements with these new out of distribution cases, maybe?
Yeah, that's sort of like phase 2. We are still collaborating, but the doctors are so much in need of such systems that, initially they came up with 10 or so problems. So we didn't have time to improve this, but right now they're saying it's working above 90-95%, which is really promising. And we started with this liver size tracking and so on problems, but we should look at more.
If you have more students, right?
Yes, but it's harder to deal with undergraduates. They are both learning.
Like the graduate students.
With 3 PhD students, we could do this in 6 months, which is really an exemplary short time
Yeah,
for
and
COVID
in the
work.
middle of the pandemic, right? While
Yeah.
the doctors are very busy.
Yeah.
So there are a few questions. They're very general. What are the challenges of making AI-assisted technology widely available in most hospitals? So you can write an essay on this, I think.
Good question. The thing is, this is an interdisciplinary approach. So we need to understand what the doctors need. The doctors need to understand what we are talking about when we say machine learning problems. So they pose their problems as such. So this is taking some time. They are two different research groups, actually. They're not talking much. So we should encourage this talk more. But then also, as much as developing this, I think we took 3 months to develop, 3 months to install this system, deploy this system, because it requires massive hospital systems to tap into, to get permissions and so on. So all in all, complicated. But for instance, the progress in retinopathy images, so there's like mobile apps. So if you are going to do it yourself, so mobile apps, I think, will be the first thing. I also heard in preparing this talk, there's the ultrasonography can be done with mobile app. I don't want to make a mistake, but so there's a lot of things happening also, especially if you don't have to install it in a system.
So there's one last question, but in the interest of, you mentioned, so the question is black box is a problem for the AI work, but you have answered this in your very last slide. So for the interest of time, I'm going to stop here and thank you and hand the slides over to Aslan. Thank you so much, Berin Hocam. This is really nice.
Thank you.
Yeah, I should talk to you more about this AI in medicine later.
Yeah, we should talk.
Yeah.
Hi everyone, we are going to have Meltem, Dr. Meltem Ballan is our speaker. Before I introduce her, I want to give a small detail. Right now she's in Texas and it is 3 a.m. in the morning. And I just want to tell that as with Istanbul, we are very grateful because she left her warm bed behind and she accepted our invitation to give a talk here. We are very, very happy. I want to give a little story how I met Meltem. 3 years ago, when COVID started, it was March 2020, I attended WiDS Stanford, it was March, and it was my first time. So when I met the organizing committee, they told me that when I met them, I said I was Turkish, and they said, "Oh, have you met Meltem?" I said, "No, I don't know who Meltem is." And they said, "No, you have to meet Meltem. She's one of our WiDS ambassadors, and she's gonna help you a lot." And then I got connected to her on LinkedIn, and since then she has been a great support. I feel very lucky that I met her. She's an expert in our area, and I think we are gonna benefit from getting to know her and listening to her speech today. And the formal introduction. So Meltem is an accomplishment leader with a unique combination of analytical and leadership expertise developed over 20 years, both in industry and academia. She's the first woman neurodiversity fellow at General Motors. She mentored hundreds of analysts and scientists as a recognized leader. She has been the advisory board member, including deep tech, M&A, and commerce. She co-founded a technology startup providing a big data analytics and ML platform. She managed large multinational and multidisciplinary projects in automotive, aviation, healthcare, software, and marketing. She established labs, she worked on academic projects, she authored over 30 publications on ML and AI implementation, analytics, and neuroscience. And today she's gonna give the talk, digital trends in the AI area. Thank you, Meltem.
Thank you very much, Aslihan. It has been a pleasure to know you throughout this process and listen to Dr. Yanikoğlu. It was wonderful. And it is wonderful to be here because This is where it all started in Istanbul for me. And this is the first time actually I'm talking as a neurodiverse digital leader. I didn't really tell anybody up until I turned 40-some that I was neurodiverse. But it is definitely an important point in my life that I was able to come out and tell everybody, because it just gives me the whole rights to come here and talk as a leader, a mentor, and educator. So overall, I spent last 30 years of my career, 20 years of my career is supporting sustainable and inclusive AI. So here, instead of giving one topic, I will talk to you about one of my favorite topics, which is artificial intelligence. It's definitely a long argued topic. And the only question here is whether AI is intelligent, and can we do generalized AI, or are we going to always stay with something called naive AI? So the outline of this talk, I really don't have an outline. I just lied to you here. It's just going to be very interactive, hoping that you can give me some perspective. You can ask your questions. So please help me with your statements and comments. Even though I will give 5 minutes at the end of my talk, I want to hear it. I want to hear you constantly, so I can adjust the flow of this talk. This is from Dennis Waitley. Dennis Waitley is a motivational speaker and a writer of a book called Psychology of Winning. So he has nothing to do with AI. But one important thing here is that AI is all about imagination and innovation. And where we are at and how we are doing the things today is way different than we were doing it 20 years ago. Today, we are looking at different perspective. We are using open source, but still the question is, is artificial intelligence really something that we are imagining, or it is real? What is your thoughts, and where does innovation is playing a role? I just want to hear you at this point, not maybe verbally, but I want to hear you that you're thinking about this innovation and imagination when it comes to the AI, because even though we talk about the algorithm quality, explainability, there are things that you cannot see on the algorithms. There are things called aptly 3 formula: attention, motivation, and perception. Those identify how you define your algorithm. So it is all in one word and summarized by imagination plus innovation equal to realization. So this is a book that I wanted to talk a little bit about, because I believe that you need to know the past in order to go to the future. Let's go back to the ancient Europe. Adriana Mayer, who is a professor in Stanford University, talks about the different machines and different ancient dreams in technology here. We human imagine and coin the concept of technology and use it to overpower others. So it is very important that we all collectively understand the backbones of technology, decide how to use it for collectively. Have you ever heard about the Pandora box and Thales? those are definitely the most famous AI tales in the ancient history. Talos and Pandora existed thousands of years before self-driving cars and robots. Talos and Pandora prove human imagination or artificial intelligence, something which cannot be explained, long before that we started to talk about the machines. Talos was a giant brass robot. He protected Crete from invaders. His veins were filled with liquid metal and ichor. He paced entire island at least three times a day, covering about 155 miles. He threw fire boulders to kill the enemy ships, and he was defeated by media by using the bolts in his ankle, and then the ichor flew out. Does it make sense that ichor is actually the oil that we use today in the robots? Another ancient story ties back to Pandora. Pandora was an artificial intelligent woman. It was an evil woman built by Hephaestus to send the earth because we found fire. She has endless miseries and punishments in her jar. Coming back to Talos and Pandora, these stories have very, very bad endings. But I don't want to give you these bad endings. I want to tell you that human fascination of AI and robots go back to the ancient history, way before than we ever imagined. I also want to remind one more thing here, that imagination is the first action to build something. And AI is all about how we imagine, how we build our systems. Technology and robots nowadays are in a different stage, and it is part of our lives. But the important thing in the news and in the lab, sometimes we forgot the importance of the human. I want you to remember that we are designing these robots, these systems, these algorithms to serve us, not to make something that we cannot use, or it doesn't make our lives easier. As an example, during the COVID, they designed a robot in Boston because they were not trying to figure out how to get to the point that they can calculate the number of COVID patients. So they sent this robot to the sewer system to collect the samples from different houses. So they came to a very close estimation of how many people were actually suffering from COVID-19. This is a great example of robots serving human. Let me bring you back to the 1800 terms. Philosopher has been discussing the logical machines actually since 1200s. Raman Yule is the first one coining the word logical machines. It is called undeniable truth of logical machines. Back then, it was more mystical, but nowadays we know that he is the first designer of the logical machines. One of my favorite scientists, though, is Leonardo da Vinci. Do you know that he designed the robots? He's one of the most prolific artists, but he was also a great physicist. In fact, he designed the first propelling robot that the General Motors sent to Mars rover. So he designed that robot theoretically on his paintings. And the scientists finally, in the beginning of 2000s, were able to mimic and realize that mission. Such a wonderful machine that you can now see it in Italy. In this chart, the modern day of AI was born with the famous Turing machine. Alan Turing was interested in understanding whether a computer can show human intelligence. The test that he developed called imitation game. The question is that whether a computer can engage a conversation with a human without a person knowing whether the person is engaging with a human, with a machine. Test obviously was not very perfect, and it started a lot of arguments, and we are still using his arguments. But when we authenticate our emails and say we are not robot, or select certain pictures, bridges, human faces, those are all different versions of the Turing test. So obviously Alan Turing has a big role in the AI. By the way, please let me know where the time is. I cannot see the time quite yet when I am showing the slides, but I want to stop in 5 minutes. So then we are coming to John McCarthy. He is actually the first one talking about AI. We didn't know that these are called AI until McCarthy. And he put this term in our heads in 1960s. He's also the developer of the Lisp's programming. If you're familiar with the first logical programming, functional programming, he developed that. And my favorite is actually a little later, that I want to talk about John Searle. John Searle is still alive, and he argues about the intelligence of the AI. So he developed the Chinese room, and you can easily design a robot, design a machine that can speak in Chinese without knowing Chinese. But if you don't give the concept, just the words, the machine cannot tell you the right sentences. So if you go back to Facebook, 5 years ago, Facebook had this wonderful conversational robot that was giving gibberish out because they didn't really train the robot with the sentences. So what is happening right now, and why are we talking here? Because what happened is that in the second winter of AI, the first winter, luckily I was not alive, it goes back to 70s. The second winter that I was actually living in Istanbul and breathing this goes back to late 90s, mid 90s. So this term of the period, we lost the grants, we lost the supports from the government, all the researchers, research institute. The reason for that, everybody was doing something, but they were doing the same thing in closed doors. So there was boundaries all over the place. Nowadays, those boundaries are really, really thin. You know, we are talking about the medical imaging with the today. We're talking about the automotive vehicles. We're talking about all in one sentence. So the boundaries are broken. We are talking about Microsoft open sourcing their codes. I mean, I couldn't believe that like 10 years ago, Microsoft was was closed box, black box. We didn't know what they were doing. So this is giving us like the human and the machine, how we are breaking the boundaries to get together to build a greater flexibility, more functions, and higher performance. Little bit about this this sentence. I'll give you 1 minute to read this, but there are a couple of important points here that I highlighted. So here, two things, artificial and intelligence. How these two words sit together. It's basically, when we think about artificial intelligence, we are talking about complex formulas. And we are not talking about something out of the box. So I want to give the example of hard computing and soft computing, and we'll go to chess and checker here. So basically, artificial intelligence was born as hard computing. It was just the 2 and 2 makes 4 or some physical rules. There was no fuzziness. The fuzziness comes from the intelligence where we start adding some noise to the data. We start adding some fuzzy logic to the data, or complexity in the sense that we are not actually seeing in data. We are giving the data some situations that that is not there. So the checker and chess is great example. Checker can be formulated because all the moves, we know how the moves happen. There are limited numbers of rules, but in the checker game, you have endless number of moves. So you can design your strategy. So here, both coming together creates this big intelligence and intelligent machines. So where it starts though comes back to human, you know. This is just a simplified version of how we perceive, how we take action. So we see object, we smell something, and we hear something. Then we start to get awake and pay attention to the certain object. And then we start adding meaning and values and emotions to that. And then we start going to identification and perception phase. And then we start to adapt to the situation. Hey, you know, nobody's listening to you, change the topic, start dancing. Or we take action, obviously start dancing. So if we go back to the actual algorithms, it's not any different than how we perceive things. So we start with the developing trends, hard computing, statistical modeling, some machine learning, robot learning, 0 and 1s, and then we start adding the fuzziness in the system. So in this first stage, information processing and determination, those are basically the phase that we are still talking about the machine learning a little bit, pre-processing, the preparation of your algorithms. That's where things become really important and complicated. Then we come to identification and perception. It all goes back to your pre-processing stage. We use soft computing algorithms like CNN, autoencoders, reinforcement learning. And then we take the action, which is the complex algorithms take place and we start moving. And it's really what I am talking is that everything starts behind our brain, the occipital lobes, and slowly moves to the front lobe. And during this period, in the milliseconds, we do this all together. So currently, we are imagining those with the algorithms. So let me tell you, since I coined this word and it hasn't been used a lot last decade or 2 decades, hard computing and soft computing, because I'm a modular person, and it makes it easier for me to imagine when it comes to designing my system. So basically, hard computing is the binary logic and numerical analysis. And then you come up to the higher level, you start talking about fuzzy logic, neural networks, and expert systems. They all become your AI. When we coin AI, we talk about the neural network separate. We talk about machine learning, robot images, but it is actually a holistic approach when it comes to the real business world implementations. So at this point, I came back where we all started, but at this point, I want to stop here and ask you what do you think? What are the trends, and what roles that we can play to make this AI intelligent? And then we can go further if we have time.
Thank you, Meltem. So let's ask this question to our attendees. Is AI intelligent? Let's give like a minute or 2 minutes for our
I can also
participants to
give the
think.
business cases if there is no question, then close it.
Are there any questions? You can write on the chat. You can write in Turkish. We can translate if you don't feel comfortable.
I can give little business cases if nobody's. There is one question.
Okay, yeah, we'll be happy.
Computers can be the...
Yeah, not intelligent. Are you trying
This
to...
is a great question, Nevin. Yes, so as I gave here, chess is actually nothing other than a mathematical formula. So we can definitely train the machines to become chess. But the problem is that medical imaging is one of the example of the naive or weak AI. I definitely suggest you guys to read weak and naive AI. You have certain numbers of images, like heart images, and then you have numbers of doctors identifying what can go with the heart. So basically, you are labeling your data. Data pipelining and labeling in the real world becomes very important. Then you give this thing, you tell your machine that, hey, there's something wrong with this heart. And then when you scan through the heart images, and when you put your heart x-ray, you will start identifying the problem. It's like, you have a picture and you have a nice family and a dog, and you want to identify the dog in the picture, and you actually label that data. There are companies in Madagascar, India, that they do nothing but labeling the data. So that data labeling aspects in weak AI becomes important. And when it comes to generalized AI, it becomes a little more touchy and feely, because you cannot do that, and you cannot really develop one algorithm to really figure out what's going on in my heart, and is there a dog in this picture. So that will take some time for us to really adjust to the environment and understand what those algorithms mean. I mean, we talk about autonomous cars. The second part was about autonomous cars. Autonomous cars are very good at understanding the roads. If you have a road and you're driving, they understand that and they stop in the red light. What if that there is a pothole in the road? Is the car gonna stop, slow down? No, because that was not in the training system. So those systems become more complicated than the weak AI.
Meltem, I have a question. So in that case, can the AI say, I'm not certain, I don't know what to do, so then just stop, for example? Like, what does the car do in that case if it sees something that it wasn't trained on?
Yeah, so it's let
Like,
me go a little bit. So it is called something, so you can teach vehicle autonomously. So one way of, can you see my screen? I think my screen is just bundled.
yes.
One way of looking at that problem, you actually use recursive algorithms, or you actually use, if it is an image, you can actually use some sort of CNN algorithms and tell that something unexpected happened, like all of a sudden the car stops. And one of the good, I mean, there are different algorithms, and like on the turn, like let's say there is a red light and there's somebody passing on the right turn. So how do you decide whether you need to turn or wait? And then you look around and then see somebody. So that decision making is a process that we use autoencoders to identify something within the system without looking at the outputs. So the autoencoders are great ways of approaching that problem, but still, we're still working on it.
Thank you, Meltem. So we have 4 minutes left to our next session, which is going to be a panel. Are there any questions?
I can maybe ask a question, if you don't mind.
Yeah, okay, thank you.
So this discussion, thank you very much for this very interesting talk. This discussion reminds me of an article written by Michael Jordan, the Michael Jordan of statistics. So he divides this into two, like AI that augments the human intelligence. So what you have also called naive AI, right? Things that we mostly do with machine learning. And the second one is the human imitative AI. So, and he gives this example of, this become a comment, sorry, rather than a question. So he gives this example that, like, for example, to develop a drug, do we really need to first create the chemist and let the chemist do the invention, right? In most tasks, we don't need that. So do you think, like, of the problems that we have in the world, like what percent of them will be actually solved by this kind of naive AI, and then what percentages? I mean, it's give an estimate, but like, do we really need a chemist for many of the tasks that we have in hand to make our lives easier?
Yeah, I mean, I wanna answer that question with Moderna. So when Moderna developed the drug, nobody knew this company, but they had enormous amount of data, and they started to label this data and then analyze what could be COVID. So in that scenario, they really left everything behind. They became not a drug company, but a technology company. So for that scenario, they just needed machines to crunch these numbers. But there are, like, as I said, we either kill the big data and then start working on something called neuromorphic imaging, looking at the certain features instead of recording the entire image. But the other thing is, like, as I mentioned, labeling, augmenting the data. That part, I don't believe that we're at the stage that we can just throw that part away and then let the computers do that. As Aslıhan mentioned, like, I don't know what I don't know. And I have the intelligence to decide what I don't know is I don't know. So you can, like, hey, something blurring the image, but it can be cat or dog. So you have the intelligence to decide, like, I don't know, but the machine is not gonna have that case where I don't know because I'm turning right and I don't know what I don't know. The machine is gonna go either false positive or false negative and then hit the target. So saying that there are cases that we can go to that point if we have historical data, if we have a good understanding on what the situation is. There is also something called delta approach. Delta approach is that you take the SMEs, subject matter experts, and they identify what can be the scenarios. Then you define your algorithms. So, but you still use human minimum 25% of the time. But for the process of defining what the best algorithm is, what process to take, you might not need human. I mean, in the past, maybe we were designing these algorithms. That part is going to be more generalist approach. So something called maybe citizen data scientist or citizen doctors, or so they will be mainly looking at the data from the perspective as a consumer.
Thank you so much.
Thank you.
Thank you very much, Meltem. So I think we have no time left. We are going to start our panel. So thanks, Meltem. So I'm going to invite our panelists. I want to welcome you, our incredible panelists. I'm very excited, and I just want to give you again a small detail. So this panel the title is Data Science in the United States, USA. The reason is we all live in the United States, and I want to tell, like, where we are located. I'm going to start with Özlem. Özlem lives in Seattle. She's in the north part. Zeynep lives in Silicon Valley. Actually, she is a neighbor of us, me. I live in Palo Alto. Şeyma also lives in Bay Area. So we are all neighbors. And Fatma is gonna move. So she's gonna be, again, my neighbor. But she was in Tennessee until 2 days ago. And she traveled for 2 days. And I'm really grateful she again accepted, because she traveled for almost 2 days and she's also moving, and she's now in Turkey. We have one from Turkey and 4 of us are from here, United States. And our time is 12:40, so it's past midnight. And we are gonna continue our panel at our network event. I'm gonna make the announcement later. But first, I wanna start with the questions. My first question is gonna be, and I'm gonna pick, randomly. Can you give a small introduction about yourself. So who are you? I'm gonna start with Shema.
Hello, everyone. I'm Shema. I don't know how personal we're going, but I was born and raised in Ankara and studied physics in Istanbul. And then after coming to States, I studied biological sciences and then found that that was a bit like too biology for me and joined biomedical engineering program and then shift my gears a little bit into more like quantitative science and engineering again. Then life happened. Got married, and I have 3 kids, 3 small kids. Yeah, that's me. And then
So
now I'm working as a data analyst at Trupil. It's a startup biotech.
Shema, you have 3 master degrees or 2?
Two masters and 1 graduate certificate in data science.
Okay. So you have a great domain knowledge, right? So you can study the data of almost like physics, biology, health, right? Like you have broad knowledge, which is very important for data science.
Yeah, that was very helpful in especially predictive modeling. Yeah, when I was working on.
Yeah, so we are going to continue with the, more questions. So I'm going to pick Zeynep. Yeah, let's get to know you, Zeynep. Who are you?
Sure. Hi everyone. Well, good morning, good evening, good night, so whichever time zone you're at. Well, I'm Zeynep. I am a research data science manager at Meta right now. I've been at this role for a bit more than a year. I graduated from Industrial Engineering Department at Middle East Technical University in 2006. And just after graduation from college, I moved to United States for a grad degree. I studied stochastic optimization at the IE department again, University of Pittsburgh. I spent a big chunk of my time of my career in retail business. And, I have always been working on optimization and forecasting problems. And now at Meta, I still spend a big chunk of my time on forecasting. This time it's more about infrastructure capacity rather than retail demand.
Thank you, Zeynep. And a small detail, Zeynep and we were at the same department, same university, and she actually are 2 or 3 years younger than me, right? And another secret, so her husband and I were classmates.
Indeed.
So the world is so small, and I didn't know. So after I invited, she told me that we were her husband and I were classmates. So I said, what a coincidence. Thank you, Zeynep. Let's continue with Özlem. Again, before she starts, Özlem is, I think, she's the oldest friend. Like since we were 14, 15 years old, we were friends. And again, we went to the same college, same department. Okay, Özlem, so who are you? Besides you are my friend.
Yeah, thanks for the introduction, Özlem. Yeah, I'm Özlem. Hi, everybody. I'm an operations research scientist. My background is in industrial engineering. I'm from Middle East. I got my bachelor's degree from Middle East Technical University. And then I went on to do a master's degree at Sabancı University. Ever since ever since high school, I wanted to do a PhD in the US. So I applied for a PhD. I got accepted to Stanford. And I came to do my PhD in production and operations management group here at Stanford. And then 6 years later, I just graduated. I interviewed at a couple of companies, and I got accepted at Amazon, and I moved to Seattle. I've been at Amazon since then. It's been more than 10 years. I mainly work on optimizing, analyzing, the outbound transportation network at Amazon. Yeah, so that's me at the high level.
Okay, thank you, Özlem. We are gonna ask more detailed questions later. Okay, so what about you, Fatma? Now you are in Turkey, but you are in
Yes.
academia, right? In Tennessee.
Yes, in the University of Tennessee Health Science Center.
Okay.
First, I would like to thank you for both this organization and your kind invitation. I graduated from Department of Statistics at Middle East Technical University. I also have a minor degree in maths. I received my master's degree again from Department of Statistics at Middle East Technical University. I was working at Ministry of Industry and Technology during my master's. Then we moved to Izmir and I started to work at Ministry of Health. And after seeing the huge databases in health, I decided to enroll in a PhD program. And I got my PhD degree in statistics, focusing on biomedical fields at 9 Eylül University. After that, I was accepted as a postdoctoral fellow at the University of Tennessee Health Science Center in Center for Biomedical Informatics. And after working in this position for 2 years, I was promoted to senior biomedical analyst in the same department.
That's great. I was a little bit jealous of Fatma because years later, in like 2015-16, data science became extremely popular, and you had to know statistics beside coding. So I remembered Fatma. I said she was the smartest. She picked statistics while we picked industrial engineering. I'm not complaining that we picked that engineering, but I wish I doubled majored in statistics. It would help. So I'm just being honest that I envied you. So okay, I'm gonna go with the second question. So okay, little bit introduction you gave us, but how did your data science journey start? And I will I'm gonna pick Shema. But you are muted.
Sorry.
So like you did so
in the same order.
Yeah, I may change it. I may pick randomly, but I'm really curious about your journey because you studied physics, biology, and then and then you tell us
here there. Well, that's why I don't want to give. I figured we'd talk probably more about this topic. So I actually loved physics when I was studying it, but after that I found out, what am I going to do as physicist if I continue? Especially
there's no money.
That for sure, but even as a profession, unless you stay in academia, there's pretty much nothing unless you teach at high school, or I don't know if you're in Turkey, probably dershanes. I don't know what's the English word for that.
Preparation.
Prep schools maybe. Anyhow, so after coming States, I actually wanted to be also a doctor growing up, so I dived into that lake. And joined actually a neuroscience program first, and actually amazed by all the biological systems, and completed almost all the PhD courses in neuroscience program, and then felt like I just trashed all my physical sciences background. I was not, yes, you use stats and you have to publish and show significance and everything, but still I was not really doing that much math or anything. So I got bored just working on microscope, and applied to biomedical engineering programs, and joined Wisconsin biomedical engineering program, and started working on cochlear implants, and took lots of signal processing classes from AA department, and that grew even more interest in my like, okay, this is the right place for me. But things are a little bit more complicated in US for PhD programs. I don't know if any of the students here, undergrad students, are planning to apply, but you have many factors in grad schools. You have to have the the best interest and best program and topic to study, but also you have to have great advisor to lead you. That's probably common everywhere, but like in addition to funding and all, you have to have everything on your plate to continue. So that formula didn't work for me, I guess. So I had to live with my second master's in biomedical engineering. And after that, I wanted to try to move back to Turkey after living here for about like 10 years. And sadly, that didn't work. I was actually at Middle East, METU, for about a year, but I guess I morphed into a different me.
So you were in METU for a year? I didn't know.
Yes. Yeah.
Is a what?
So I was a chronic graduate student, so I was biomedical engineer.
I told you, you did more than two.
I don't include that in my resume or anywhere because that would even confuse minds a lot more. So yeah, I was there for a year, but yeah, I was not. To be honest, I was not happy.
So like you came back to United States and then
I came back and then so during that time I got married and had my first child, and I was raising him, and then when I decided to go back to my career, it was very, very difficult. I had about like 6 years gap. So although I had degrees in states, that was very challenging. But I joined a lab in that time we were in Houston. So I joined a research group to work on predictive modeling using brain images. It was a Center of Mood Disorders at UT Health. So that was actually a great place for me to get back and get back on my feet. And yeah, that was my actually introduction to data science. So that's long summary. Then I started working at different groups, and yeah, have published works in predictive modeling, and yeah, I'm not a data scientist right now.
But you're a data analyst.
I'm data analyst, but this is a startup. That one of the reasons I joined this company is we have pretty large data group. So we're just forming the data science group now. So we have tons of data to work on.
Also, the titles keep changing in the last 5 years, right? Data scientist, applied scientist, data analyst. So lots of data. Companies keep changing. Thank you, Şeyma. I'm gonna go.
Thank you for being patient.
But so I think in the network event, you'll get lots of questions because we all have similar. I mean, we all intersect. We all had kids. We all graduated from. I mean, in United States, it's not easy, right? Even just getting a green card without a working permit, you cannot work. It's not easy. So I'm sure these questions will come at the network event. Okay, Zeynep, let's continue with you. How did your data?
Randomization.
Huh?
There's
Do you
no
remember?
randomization.
Randomization. Okay. Well, next round. You tell me how your data science journey starts.
Well, my journey has been quite straightforward compared to Şeyma's story. It might be a bit boring, but the first time I assumed the data scientist title was in 2014. I started working at Lyft, the ride-sharing company, and since that job, I have been a data scientist. And before 2014, my job was about, working on data in a business domain, understanding that domain, building insights on that data, even that domain knowledge, building models to address the business needs in that domain, and working with, customers or partners on adoption of the results of the models. So these steps have been the same since I became a data scientist. So what was different, like before and after, was basically the size of the data. It exploded. And well, of course, like the size of the data basically changed the nature of almost all the steps in the process. But, the big picture has always stayed the same. I'm like at a high level, still doing the same thing. It has been a title change for me. Like the models that we have been working on, well, it is different right now, maybe. Like how we munch the data, how we approach the data is different, but at a high level, I was a data scientist and I'm still a data scientist right now.
Now you're a manager.
Yeah.
So you're managing a team, right? How many
Yes,
people
indeed.
are working under you? Don't be modest.
Yes, well, I have like 10 team members and they're awesome. They're doing a great job, but there are cases where I still, roll up the sleeves and get my hands dirty.
Yeah. Nice. Thank you, Zeynep. And you said randomization. So next round, get prepared.
Okay.
You'll be the first. Okay, Fatma. So actually you started when you were 18, when you first started college. When were you introduced to data?
Yeah.
Tell us about your story.
As you said, I have been always working with different types of data. So I did not experience a sharp transition to data science. Maybe I can tell you a different story, like how I selected a statistics department.
Okay.
As we all know, there were no concepts like machine learning, data mining, artificial intelligence 20 years ago. And at that time, my husband, we were in the same class in the high school, he was saying that now computers have started to keep a huge amount of data sets, and in near future, companies, universities will need people to analyze these big data sets. And you like working with numbers, you should choose this department. So he convinced me to select this department. And he was quite right. I was always so happy to work on this field. If we talk about my, do you want to say something?
Yeah, so I'm curious what your husband picked. What did he study? So he picked picked your job. What about
mathematics? Then now he's a data scientist too.
Yeah, so he found the right
yes,
way.
But now he's working as a yes.
So are you teaching him
and
statistics? Are you teaching him statistics?
We are teaching
each other. Yeah?
I teach him statistics and he teach me mathematics, and we are a great couple.
That's great.
Yeah. If we talk about my experiences in data science, in my senior year, the concept of data mining began to very popular. And I got also my master's degree on this with a thesis on the usage of data mining techniques for quality improvement in a manufacturing industry. We got a project grant also from TÜBİTAK with the professors from Department of Statistics and Industrial Engineering. At that time, it was very difficult to find enough data in manufacturing industry in Turkey because data was not being kept properly. So you either had to collect this data prospectively or simulate the data. After I started to work at Ministry of Health, I realized that health industry is data heaven. There are various kinds of databases. You can find any types of data. You can do whatever you want. Then I immediately started working with physicians, and I had the chance to recognize and analyze the data sets in different fields of health, like data in intensive care unit, obstetrics, pediatry, neurology. And during my PhD, I worked on risk-adjusted hospital mortality rates and used several machine learning algorithms. After that, we moved to US 3 years ago. And as you said, currently we live in Memphis area in the state of Tennessee. This city is one of the health hubs in US. Maybe one of the 4 buildings in this city is related with health, and research is being done in different fields of health. St. Jude Research Hospital also in this city. It is one of the top 3 hospitals working on pediatric cancers in US, and there are a lot of research going at this hospital. What I want to say is if some of our participants are interested in data science in healthcare, Memphis can be a good place to start and improve yourself. Because when there are a lot of institutions around you doing research on health, then you have the opportunity to work on different projects. For example, in my lab, I sometimes work with cardiologists and use their ECG and echo data to predict the risk of cardiovascular diseases or other diseases with vascular pathology. Sometimes I work with radiologists and use their CT studies to detect some disease. You can work with genetics data. And since the scope of biomedical field is very wide, we can work on different projects and we can use any techniques that we want in these projects. We mostly use, of course, machine learning, deep learning transfer, but sometimes we use parametric methods as well. To wrap up, if you want to work on biomedical data analysis, you will not have trouble to find a project to work on it. You will just need to decide what you want to focus on.
Thank you, Fatma. Okay, so next question is gonna come. This question is, so I'm gonna randomly pick Zeynep. I'm gonna start with Zeynep. So the question does not apply to everyone. So I'm gonna change it, that doesn't apply to the, so it will be like reverse order. So if you did PhD, if you were in academia, mostly like in States, if you do your PhD and postdoc, like you start applying faculty positions. But this wasn't the case for most of our panelists. So if you did your PhD and postdoc or just PhD, how did you transition to industry? Have you ever thought about working in academia, or you just knew that you were gonna work for the industry? So I'm gonna start with Zeynep, and then I'll go to Özlem, and then I'll change the question a little bit for Fatma and probably Şeyma. Well, no, actually Şeyma, yeah, not Şeyma. Your question will be different. So, okay, let's start with Zeynep.
Sounds good. Okay, well, I do have a PhD, and after getting my PhD, I started working in the industry right away. And now
Zeynep, how did you, what about the working visa? Because this was a problem, and that's one of the reasons I applied for faculty positions, because getting a green card is easier. So how did you manage that?
Yeah, I was lucky. Like I graduated from grad school in 2011, and that time there was a great, demand supply balance. I did not have any immigration concerns.
Okay.
But finding a first job is difficult, and finding the first job as an immigrant is even more difficult, because not all companies are supporting the immigration process. It is heavy. So in today's world, it's different. For instance, in 2008, it was different. But when I graduated, I was lucky. I only, stressed out in terms of finding a job while writing a thesis. That's fun at all. But at the end, it worked out well. When I look back, I do not have any regrets. I would have chosen a similar path if I were to do it again. If I were to do something differently, I would have maybe looked for internships during summer times at grad school, because what I see right now is that those internships are a great way of like gaining experience. You get your hands dirty, and that actually grounds you so much. Early on your career, you get to see the value of what you learn at school. And because it's an internship, you're going to go back to school. So you identify the required skill sets, you observe others, you see what matters, and then you get to work on those like skills. You can invest on those skills when you are still at school.
Thank you, Zeynep. Yeah, so great recommendations. I agree, totally agree. So what about you, Özlem?
I never considered academia. I think I have no I have no regrets either. Just
you know, like, so your school Stanford, you know, is a brand, and it will be easier than, you know, other colleges to get accepted as a faculty. But you say you never wanted to be in the academy. So when did you decide that?
I think at the beginning, I pretty soon discovered that research takes time, and for me, writing papers is too slow-paced. So I prefer the fast-paced industry environment where I can see the impact of my projects, what I do sooner, much sooner than in academia. I think I would have liked teaching though, but still, I think the disadvantages of doing that research and publishing papers is way too much.
Do you publish papers at Amazon? Because you're a research scientist, right?
Yes. People do, and I did not. But I will try to do more of that in the future. But it's kind of more difficult because you have to pass this process of getting approval, and you cannot publish too much of confidential information.
Right.
You cannot give too much of the what we call the secret sauce away. Yeah, it's a bit more involved, but it is doable. Yeah.
Özlem, actually, I think I skipped you, right, with the second question, like, right? I mean, have you heard about your data science journey?
I can talk about it now.
Yeah, right. I skipped you. Okay, I'm so sorry. So
yeah, no worries.
I know you studied industrial engineering in METÜ, and then also Sabancı University, and again Stanford University. When was the time you first, you know, had your hands dirty, as Zeynep explained? And so when was the first project? I don't remember.
2010, 2011 is when I started working.
Okay, so not during PhD.
No, so during my PhD, the main data that I worked with was, you know, the data that I generated. It was synthetic data. It was very small. And then when I started working at Amazon, it's like people told me, okay, go get the order level data. Here's the table, and, you know, go learn it. And and so I started learning all these things. And I got the data, and I downloaded to my laptop. I tried to open it in Excel. It's like pretty soon you hit the wall.
So like billions of rows, like how big was the data?
So I tried to fit it into Excel, and I was like, oh, then it's text editors, but it's now quickly it became untenable. And one day a colleague of mine said, okay, there's this scripting language called Perl. And and I said, no, is it like the pearls that we wear? It's like there's a different spell. Like, I don't know if people know it. Even I'm that. It's pre-Python era. So that's how I started, my data journey.
So
yeah,
it was
it's basically
challenging
on
at the
job.
beginning, right?
Yes, it was
Like,
very challenging. Yeah.
were you discouraged? Like,
The thing is, I always liked, math since I was a kid. You know it, and it's like I like solving puzzles, and it's like OR and data science is like solving puzzles with data. I really like it. I can
so after
yeah.
so you learned using Perl. So
Yes, I learned using
and
Perl, and then I
it
learned
was
R,
easy.
and
Yeah.
it became easier over time. And when I switched to Python and Java, then things got easier.
Okay, easier.
Yeah.
Okay, that's great. Okay, so you're happy. You never thought about academia, so no regrets, right?
No.
Now I'm gonna ask. Actually, we kind of heard about your story, Shema. How, but then you didn't give more details, right? So you moved from Houston. No, you started working with the images, right? In the lab, you started working. And what about okay, so right after that, maybe you can tell us, you said you are working at a startup. No, but before you worked at Accenture?
I was
Google.
with Accenture when I was working at Google. Yeah.
Okay.
That was my first industry job.
Okay. Yeah. So maybe you can.
Yeah. But I want to mention one thing. Unlike all the panelists here, I really wanted to get PhD. As you can tell, how many programs I started. So I don't want to really downsize getting PhD, especially in that, because you didn't really probably see how advantageous having that ultimate degree. With me, yes, I had the domain knowledge, and I had especially when I started working on these predictive modeling using clinical images, I self-taught myself Python. Yes, I'm not a computer scientist, or I'm not a coder, hard coder, but I was a coder at my level. I mean, I could develop, train a model and get results in machine learning and deep learning and all, but it was very difficult for me to find a job because I didn't have PhD. So they didn't really, and at that time I didn't have any work permit either. I was already green card holder. But it was very difficult for me actually get an industry position. So I wouldn't want to make it sound like getting a PhD not maybe necessary or something. So it's definitely useful. Yeah, that's one thing. But I guess a new generation is a little bit different than my generation or our generation. We didn't have the luxury having maybe computer at our home in elementary school or middle school. So maybe they have the advantage of being an expert in coding. So it might be easier, especially if they have, these tools lining up when they go abroad. But yeah, I took a volunteer position for about like 8 months. During that time, I worked with clinical images, and then I worked as a researcher. During that time, I took these classes in machine learning, deep learning, and all. But then I couldn't find any full-time position, so that's why I accepted Accenture. So I was working at Google, but as an Accenture consultant. So it was okay. I liked what I did, but it wasn't anything related to data science. So when I had this opportunity, I just jumped on, although it's nothing compared to Google, yeah, that's pretty much the whole journey, I guess.
So I think we have like 15 minutes left. So I'm gonna ask my last question. So do you have any challenges of being a female in the tech world? But actually, right, Fatma, I forgot, actually, I skipped you. When you do this randomization, you may forget, some panelists. So I was gonna ask you that you started with the industry, because I remember when we graduated from METU, we applied for grad schools, and I think I remember you directly started with industry, and then from industry
Yes.
you, but actually you told your story, right? How why you were interested in academia. You were working for the Ministry of Health, and then
Yeah.
right? Do you want
Yeah.
to
As-
repeat like shortly, and then
Yeah,
we'll
maybe
go to the next
2 or
question?
3 sentences. I
Yeah,
can summarize everything. Yeah, as you said, I worked at different ministries in Turkey. But while I was working in these government institutions, I was trying to continue my academic life as well. I was doing projects with other people. I had some friends who were PhD students in US and Europe, and I was always in contact with them. And I was trying to apply everything that I heard from them by myself. For example, they were saying that Python is very popular here. We use Python in all our projects. Then I immediately started learning Python by myself. I have always been interested in hands-on data analysis project, but of course it was so difficult to manage all these things while working at a full-time job. Now my only responsibility is do research and publish them. So I am doing exactly what I want to do right now, and I am so happy to be in the academy.
That's great. So you want to continue with academia, right?
Yes.
Are you open to
but
industry
I think
options?
in US, yeah, but in US, I think the companies also do a lot of research. So working in the
Right.
company or in the universities, these are not completely different things from each other. Yeah, I can continue with a company also.
Right,
I haven't
right.
decided yet.
Yeah, like research department. Okay, so last question, just 2 minutes each of you, because we don't have enough time. So what challenges you faced as a female, or have you ever faced any? Maybe none. So I'm gonna start with Özlem.
Okay, that's the toughest question, but the smallest time. Well, I think this is a tough question. Yes, people have, I think people are talking about salary disparities, missed opportunities with being projects or work-life balance, but I haven't experienced any one of them. But what I experienced was conversations and cultural differences between male and female. If the culture is like, let's say 80% male, if the workplace is 80% male, unfortunately culture is, affected by that. Then 80% of those people, what do they bring to the table? And I don't want to make it, generalizations about like men are like this, female like this always, but there is a general trend that I observed, which is women are more reserved and less speaking less, I should say. Men are usually don't have any problem with speaking up, speaking over each other, interrupting others. So I have faced, I have been in the meetings in the past, in the environments in the past where people are speaking with each other, and if I wait for someone to speak and finish what they are saying, I could never
Right.
express my opinion or express my view.
Yeah.
So what I had to do is learn to speak up and learn to express myself, because when you think that you know, women are generally like I am. That's what I'm observing, and it's like if you don't speak in these environments where, you know, when you are managed by and generally assessed by this 80%, then people can assume that you don't have an opinion, or you don't know things, or you haven't done your job. So basically, you need to change like how you were brought up and adapt to that environment. I think the solution is not for women to become like more men, like men, or men to become more like women, but we need to somehow meet in the middle.
Right, I
Yeah.
agree. Thank you, Özlem. What about you? Okay, I pick Shema. Any challenges?
I'd say it was a little hard for me to maybe differentiate being a female or I mean, because like we were about like probably as contractors like Accenture consultants, we were dominantly women, but the Google side were all men. So I don't know if it was FT versus, you know, woman, or, I mean, it's hard to really distinguish, but we were definitely suppressed. But I mean, as probably you can tell, I'm pretty vocal, so I don't typically stay quiet when I see something or when I feel not comfortable. I'm pretty vocal. And I was actually pretty welcome. And when I told them I was leaving, they all expressed how sad they were and everything. So they really appreciated, I think, how I was outspoken and all. So following up, you know, Özlem's point, I think they didn't really judge. It's just maybe the expectation, or I don't know, like it's natural, maybe understanding, like woman versus man, I don't know. And now we're pretty much equal at Triple, so I don't have any issue with that.
Really, like 50-50%?
About, yeah. In data team, it is pretty balanced.
That's great.
Even in the management side, so it's really nice.
That's great. What about you, Zeynep? How is Facebook?
Well,
or just challenges before Facebook, maybe?
Yeah, Facebook is actually quite good in terms of all these, like, you know, imbalances, biases, but there's always room for improvements. I think in general, being a woman in tech is kind of like being a minority, especially management. It's kind of like being alone, like in a meeting room. I'm so, you know, used to be surrounded by male colleagues only, and I love them all. I mean, they're all great, but it doesn't change the fact that I be the only woman in the room most of the time. And I believe as a society, we also have internalized this situation so much that without any conversation, nothing, you know, spoken yet, like the space that a man occupies in the room is way more than the space a woman takes in. And this shows up, for instance, like you might have, like, you know, seen like how males sit in meetings time to time, right? So I've never seen a woman doing that. Listen, you know, how we, like, you know, attending to the other person when they are expressing their ideas. And of course, like all these like little details impact how the business is being run. Like the amount of credit, say, a woman takes versus a man takes for the same job. Because like we tend to, for instance, share that credit. We don't say, well, I did it. We tend to say, we did it. So, well, in United States, there are so much, you know, so many efforts to bring in more females into tech. And like, you know, there are many efforts to remove the biases, but there's still room for improvement. Meta is definitely, you know, a step like up compared to some other like positions that I assumed. But even like, you know, within, I think, Meta, Facebook, there's room for improvement.
Thank you, Zeynep. And okay, Fatma, you're the last. What about you?
Yeah.
Do you think you have any challenge? Yeah.
Honestly, I have never been in a male-dominant environment during my education and work life. What I see in US is here people generally support each other. They especially support the young researchers, young female researchers. I don't know, maybe this is the case in universities and this may be different in companies, or maybe I was so lucky, I really don't know. But I did not any negative experience on this.
Okay, it's great to hear. Okay, so I see we have some questions, but I think we have no time. So what we are gonna do is we are gonna split into three. Fatma, so Öznur and Özge, if you are here, you can turn your cameras on. So Fatma and Şeyma, you are going with Öznur. Özge and Zeynep, you'll be in the same channel. Meltem, do you wanna, I don't know, if you are awake, you may wanna join us. Is it possible? Right, Meltem can pick us, right? So can we share the network? I don't hear you, Öznur, you are muted.
So
can we put it on the chat?
Yeah, that's what I'm gonna do. Just give me
Okay.
1 second and
Okay.
you will get the info. Yeah. By the way, Meltem has a question on the chat too.
Yeah, do you have any male data scientists in the audience? If yes, how do you take this perspective? Do we have any males?
Are we talking to each other again?
I mean, we choose webinar for this event because it's easier to manage, I think, but it kills the interaction. So that's why I think it's difficult to get to know the attendees. But this networking event is going to be great. So we
Yes.
don't know yet whether we have. Let me.
Meltem, if you join our channel with Özlem.
These are going to be Zoom meetings, so it's going to be interactive there. Yeah.
Okay, so it's going to be in Turkish. So it's going to be questions, answers.
So I just put it in the chat box, so everyone can see it if you click on there. These are the 3 channels, and we will be meeting you there in like 2 minutes.
Okay, so see you guys. Bye.
See you. Bye-bye.
Bye, guys.
So let me show you my homework, basically. My lecturer was like, oh, you are hosting it online. So for instance, I can just drag and drop image and I pick, low pass or high pass filter, and I pick my kernels and cutoff frequency, and it's basically a Fourier transform. I also made one for the spatial domain transformations. So I'm going to make them like all together to make a very big image processing application. So for instance, I have hosted an exploratory data analysis application here. I'm going to show you. So Streamlit has its own nice components. I really like them. So I have a data set consisting of, let me show you the, so you can find the link data set here. I have a data set of the poetries with their author and, you know, the age they are written and their type. I wanted to do an exploratory data analysis for the sake of doing it, and I didn't want to use any notebook because I find it messy, and I didn't want people to, like, if people are not interested in your code, especially, it's messy to show them a notebook, especially if you have clients or like someone who is not understanding from machine learning. So it's good to use something like Streamlit in that case. So for instance, Streamlit has this interactive data frame component that you can play with, like this. For instance, for this, I have just, where is it? So I have downloaded a couple of libraries, but they are not necessary. They are for the text processing, basically. I have taken this data set and standardized the text. So if you are doing natural language processing, it's good to lowercase your text, get rid of punctuations and everything to see the distribution of the words, basically. So what I did, I applied my transformations to dataset, and then I called st.dataframe stream. This is the short for Streamlit, st.dataframe, and passed my data frame, and it's just this. And I made a couple of data visualizations. If you are familiar with Matplotlib and Seaborn, or I don't know, anything like Plotly, you can just write your, you know, plots, and you can call streamlit.pyplot to put it inside your application. So for instance, I wanted to see the dataset statistics on, you know, like there are types of poetries like mythology, nature, love, and I wanted to see the distribution so I can get a sense if like there is so many love related words, and my model eventually can have biases regarding that. And I also wanted to see them for each age. And also, nice thing, I think this was Seaborn, yeah. So this is another Seaborn plot. So I just called st.pyplot, and a couple of other plots regarding my data. And you can even do like a word cloud and then call again inside the function st.pyplot and just call the word cloud, and it will be here. So you can see how the language changes according to ages. And lastly, this is a really cool one. So Streamlit also has its own plotting components like st.barchart. I wanted to print the most used words, and you can just, you know, it's quite interactive. You can scroll and you can do other stuff. You can just see the bars and everything. So yeah, this is an EDA, and I'm going to show you a couple of other stuff. So for instance, so this is my friend's lab work made with Gradio. He has used a PyTorch model, and I'm going to show you how to build a very basic Gradio application. So basically he has brain MRI data, and he generates an MRI it's like a conditional generation with GANs. So what you provide in here is the seed and your noise and the truncation. I think this is pixel limitation, sort of. I am not a computer vision professional. I am just going to show you how to build an interface. So basically this is a ready to use interface. So you call gradio.interface and you provide your inference function, which is written here. I'm going to come to that. So the most basic thing it takes is inference function, your input and output components, which are related to your inference function. These are the most basic things that your Gradio application takes. If you want to give them an example, you can also provide them an example. If you want to provide a description and I don't know, title for your application, it's also good to do that for the sake of UX. So you can provide them in your interface as well and just call the launch and your application will be ready. So basically, if you want to create an interface, just call grade your interface, pass your inference function and input and output, and that's it. Like in 2 minutes, you have a ready to use machine learning model. And like, for instance, the prediction function is like simple. You just call your model and provide your inputs, which should match here with your input. So basically you have a slider, right? The list you provide should be in alignment with this if you have an prediction function. And you return your image. It can be like a pillow image or whatever. Yeah, and that's it. You can just load your model, like if you have pickleized it or if you have it on Hugging Face, you can also call Hugging Face. But in here, he clones a repository. It's the StyleGAN model. And he just gets the model, writes the inference function and calls the interface and calls interface.launch. And you just drag and drop this to, like, you create your, not the data set, sorry. You create your space, like for instance, brain image, whatever. And you pick a license for your model so people do not just copy this, and pick the SDK. It can also be static, and just create the space. And like I can just add file by dragging and dropping the application file that I have just shown you, and it will build it for me. And if you have additional packages that you want to use, you can also provide packages TXT file for Debian packages, or requirements TXT file for Python. So for instance, in here, he has used a couple of other packages like Torch and Torch Vision. You can provide this. So what it does is that, like, it creates like environment, Python environment in the background, and it does pip install all of these packages and just runs the application file. So it calls Python app.py and your interface is ready. Like, you don't need to do any of these. And lastly, this is my favorite one. So basically, this is one of the most famous applications of Hugging Face back when transformers were out. It was so hard to demonstrate them, and just like they have built this website that serves transformers models. Like for instance, you can just write GPT-2. Hello, I am Merve, and I'm going to press tab, and it will complete for me. Yeah. It usually doesn't make any sense, but it takes a couple of parameters. So generative language models take parameters such as temperature or sampling related parameters like top P, decoding parameters, that determine how your text is going to be random or conservative. So if it's going to be very similar to real life text or very random. I have built this in Streamlit. I will shortly show that to you and then just finish my talk. So as you see, I did the same thing. I am taking same parameters and even a top K parameter, which is like a random decoding parameter for language models. And I can just write, hello, I am Merve, and comment enter. And it completes it here for me. So how I did this, very shortly, I'm gonna show you. So I have loaded, so this time I didn't use any abstractions for the sake of showing an decent inference function. I have loaded the tokenizer, which is like a preprocessor for text applications that turns your words or subwords into numbers so that your model understands the real life. And I am loading the model from Hugging Face. This is not necessary. You just need to know that I'm loading the model, and that's it. And if I cache this, it will load in shorter time for me. So I cached it. And I am writing an inference function. It just calls models on generate function. And as you can see, it takes the text, which is input IDs, but like text, but tokenized. Maximum length, it's going to generate temperature and top K and top B, which is used for the randomness. And in here, I am taking these hyperparameters, you can see, and I'm going to assign them to variables so I can just pass them into my inference function. And it's not like an interface again. I am just going to call the inference function and print the output of the inference function below, which is here. So in here, I have input takers, which are like sliders. I have an explanation here, which I wrote with st.title and st.write. In here, I have text input, which I tokenize the input of this and pass it to the inference function. It's called input IDs. And in here, I am just printing the output, and right on time, I have finished my talk.
Okay, Merve, great. Thank you.
Thank you.
So there is a comment. This is very nice. Actually, as you say, one use case is like in the courses. Yeah, I'm teaching graduate level machine learning, and like grading projects is always an issue. So it's very helpful. I'm gonna check it out in more detail, but you showed very neatly. So so there is one comment here. Elif, our next speaker, commented that we are big fans of Hugging Face in our team. She's
I'm also a fan of the company I'm working for. Relatable.
So, and Müjde Güner is asking, are you going to be continuing your Twitch sessions? So she used to join them, I guess.
So reason why I stopped, so basically I was teaching people data structures and algorithms and other stuff. So reason why I stopped was because in Turkey internet is very slow, and my streams were being very sabotaged by the internet service providers. And now that I'm in France, I think I will continue once I get everything settled. Yeah. If you
Thank you so much. I don't see. Yeah,
if
that was what I was.
You can just ask from Twitter. Like I have a Twitter account. I'm gonna leave it here.
Yeah, that would be great.
I'm gonna leave it in the chat, so I do not want to take any more of your time. Thank you for listening.
Thank you so much. Thanks. Okay, so our next speaker is gonna be Elif. Elif, welcome. How are you? So while you are sharing your screen, maybe I can introduce you. Dr. Elif Özkırımlı is the head of data science at Pharma International Informatics at Roche. She leads a global team of data scientists that focus on understanding the patient and healthcare professional journeys, as well as on building commercial decision support tools to achieve better patient outcomes at a lower cost to society. The group builds state-of-the-art machine learning models and advanced mathematical models. These models are usually interpretable and provide trustworthy insights, which is critical in the medical domain. Dr. Özkırımlı holds a BS and MS in chemical engineering from Boğaziçi University. She has a PhD in structural biology, and until recently, she was also a faculty member in the chemical engineering department at Boğaziçi University. So we are very excited to hear you, Elif, today. Go ahead, screen is yours.
Thank you very much. Can you hear me and see me and see my slides?
Yeah, we can see.
And can you see?
Yes,
the title?
Mouse as well.
Perfect. Okay, great. Okay, so you know that I cannot see you, so please feel free to interrupt at any point if you have any questions, or feel free to write in the chat. And I'd like to thank the organizers and Öznur very much for inviting me to this really amazing lineup of women in data science. It was a pleasure to listen to all the talks and the the panel discussion. So today I'm going to talk to you about natural language processing of biomedical text and how lucky I am that Merve gave such a good introduction to NLP and also to the Hugging Face environment, which we, as I mentioned in the chat also, which we are huge fans of. So I will talk about NLP of biomedical text, and I will highlight some of the industrial applications and also some of the scientific applications of NLP in life sciences. Okay, so after a very brief introduction about NLP and life sciences and some of the opportunities, challenges, some specific aspects of it, I'll describe 3 different examples. One of them is healthcare professional feedback classification. Healthcare professional in Roche speak means doctor. Roche has interactions with the doctors, and these interactions are collected obviously in text form. So this feedback classification is one of the use cases, one of the sort of a use case summary that I will give so that it drives some of our research as well. So I'll talk about scientific literature classification. In this case, the text will be biomedical text, meaning publications. And then the last piece of the talk will be on protein compound interaction prediction, where in this case, the text will be proteins and compounds represented in string format. Okay, so what is the text data in the biomedical domain? I mentioned about opportunities and challenges, right? So it can be natural languages, meaning this highly domain specific, but still in the way that we would speak or write. So these are some of the natural languages. But at the end of the day, these are also codified by human beings, right? Whatever we speak is codified by human beings into some sort of string. And so you can think of these as representations as well, obviously. And this can be in multiple languages, even though most of the publications or most of the text is in English. This is also something that's true. But as a company, obviously, we're working with many different countries and affiliates, so we do have multilinguality as a main focus. But at the end of the day, these are natural languages, the way we speak, right? Spoken language. But there's other sorts of string representations of biomedical knowledge in the form of DNA sequences, protein sequences in amino acid sequence form, and then chemical formulae, which can be represented as string-based representations of compounds. And here I'm showing you a SMILES representation, which is a very commonly used representation of compounds. But there are others, of course, such as selfies, etc. And I will try to briefly mention about how this domain specificity in these biomedical texts is a challenge. This is true, but there are now language models or other tools that help us process this data, right? This highly domain-specific data with heavy focus on, let's say, keywords and specific terminology. But the other challenge is the following. We just don't have enough data to sample all of the knowledge space. So finding the relevant information for publications, from protein compound interaction space, or from these interactions with the healthcare professionals, we just don't have enough examples of all of the knowledge space, because A, it's very expensive to collect some of this data and it's very expensive to label it, but it's also sometimes impossible to sample all of knowledge space because of, for example, challenges in protein purification or synthesis of some chemical compounds. So I'll try to focus my talk on the challenges that are associated with data scarcity. So let's start with this example use case, which gives you, I hope, a sort of an example of what it looks like in the industry, this use case and its development. Okay, so we are part of the IT organization, so we are sort of the enablers of the subject matter experts within the company. And here, Lisa is our subject matter expert, and she would each month manually check all of the healthcare professional or doctor feedback that is received from the doctors. And then she splits the free text into several sentences based on her experience. I told you that she is our expert, right? And then she classifies each sentence, insight and non-insight. And then the insight sentences are classified, for this case, into 7 areas, according to the Roche department that will handle the insight. So she's helping with the triaging of this text. But you see that it takes 2 days, and it requires manual effort. It's time consuming. It's usually an external agency that we work with that helps with this classification. And there are inconsistencies in classification that become a challenge because Lisa, if Lisa is the only one that's doing it. So these were some of the problems that we received from the requester, and we decided to build this data pipeline, which is a very straightforward one. We just start with data ingestion, train machine learning models, prediction of class, and reporting and visualization. This is a very common data pipeline in an industrial setting. But one challenge remains, and I mentioned this to you about the inconsistencies with the blue and the yellow dress, the inconsistencies in labeling. And it's hard to annotate data consistently. So the cat pictures on the left, you can see that they're clearly cat, and the not cat pictures on the right, there you can see that they're not cat. But what about the ones in the middle? For those ones in the middle, unless you have some sort of rule, it's very hard to classify them, right? Even for a human being, you would need to tell them, if it's a drawing of a cat, then you can label it as a cat, something like this, right? So you would need to give some guidance, and the subject matter expertise is actually what comes in handy here. And I mentioned to you that we just don't have enough data to be able to build these machine learning models with high accuracy and precision. So we included this active learning as an additional piece of information to include the subject matter expertise, which is already available in the company, right? So you remember Lisa was doing this, but if we can support her to not worry about some of these easier or high confidence labels and focus more on the low confidence labels for correct the mislabeling and to add labels to the unlabeled feedback, then this saves time. And indeed, so for this use case, this feedback classification powered by our internal NLP engine, and this internal NLP engine, I have talked about it in different settings. So I think this is also available in different talks, but I won't focus on this for this talk. So this is our, let's say, bread and butter flagship use case, where feedback is received and the goal is to understand the customer being, in this case, the healthcare professional, using state-of-the-art machine learning, which is continuously improved by this human-in-the-loop system. It is scalable to different number of labels and amounts of data. I mentioned to you about the 7 labels that needed to be, the 7 departments that needed to be processed. Now we have use cases where, or projects where we need to have 150 different labels. And it has multilinguality, it's faster, and it saves money for us. So this was a text classification use case, but you saw that active learning was actually very powerful to make sure that we were able to include some examples of knowledge space that weren't accessible at the beginning as labels. So let's start to layer on a little bit more science and look at text data in the biomedical domain. And here the focus is more on publications. And the goal is to classify publications with multiple labels. So this actually is very similar to our previous use case when we have 150 labels, because there may be some pieces of text or some pieces of feedback where each feedback may have multiple of these labels. It's a very similar example here. This abstract that I'm showing you is from a publication, and you see that it has it's talking about COVID-19, ICU bed occupancy rate, and it talks about, for example, infrastructure, material allocation, ICU staffing, etc. So these may be some labels, and human will also be a label. But you can imagine that there will be lots and lots of publications with the label human or with the label COVID-19, especially in the last 2 years. And therefore, finding those needles in a haystack is even more challenging for multi-label text classification due to class imbalance and co-occurrence. So what does class imbalance mean? It means that some labels are so frequent, such as human or COVID-19, that they completely overpower the machine learning algorithm. And then co-occurrence means, for example, COVID-19 would co-occur with ICU, but COVID-19, you may have hundreds, thousands of samples for it, whereas ICU, you would have only a few. And if you were to make a prediction to say, oh, I'm going to just label all of this with COVID-19, then you'd be missing the ICU, that rare label, right? So this is, as you see here, sort of a representation of this class imbalance where you have many articles for some of these labels. So those are the head labels, and only a few for some of these labels, and those are the tail labels. And here I'm showing you that some of these head labels here co-occur with the other rare labels. Okay, so we proposed, actually it was really nice to see also in Gözde who just talk about this loss functions, these different loss functions applied to the CV space. Here we're also sort of borrowing some of these ideas from computer vision space, where obviously these are some commonly used methods, right? Binary cross entropy or resampling and reweighting, but these are not effective, especially when you have label imbalance or label dependency or co-occurrence. So we proposed a novel approach using distribution balance loss with 3 layers: focal loss, rebalanced weighting, and negative tolerant regularization, to make sure that we were able to also achieve high performance for the tail labels. So here I'm showing you, and our metric was micro F1. Here I'm showing you a comparison of distribution balance loss with these 2 baseline methodologies, basically. For the total performance, when you look at the total performance, this distribution balance loss is on par, if a bit better, with support vector machine or other baseline methodologies. But especially if you look at the tail labels where you have fewer samples, then the distribution balance loss increases the performance in terms of micro F1. And this paper was recently published last year, actually, in EMNLP, as balancing methods for multi-label text classification with long tail class distribution. So I did mention to you that text data in the biomedical domain is not only natural languages, such as captured in healthcare professional interactions or in publications, but also in terms of DNA, protein, and chemical sequences or string-based representations of such biomolecules. And so I'll give you my 3rd example will be in the protein compound interaction space, where proteins and compounds or ligands interact with each other at some different affinities. Some of them with high affinity, strongly, and some of them with not so high affinity, or even they don't interact with each other. And making a prediction about the affinity of protein compound interaction is actually a very powerful step, toward building these or toward designing or discovering these novel compounds that may be effective as drugs. So this is part of the drug discovery pipeline, where predicting the binding affinity as in a sort of a regression type of setting of protein compound pairs is one of the first steps that enable drug discovery and design. And proteins and ligands are actually three-dimensional shapes that are dynamic, but and proteins can be represented in string-based representation, and ligands can also be represented in string-based representation, as I showed you in my one of my first slides. The challenge with 3D or this three-dimensional using the three-dimensional shapes of proteins and ligands is the fact that not all of proteins and all of ligands and protein-ligand complex pairs are structurally determined. So we don't know how they actually look like in three-dimensional space, but it's relatively easier to have access to the sequence or the protein sequence or the chemical structure in string-based representation. So using this information actually gives us more access to a wider or a larger piece of knowledge space. Okay, and recently we proposed several models where we used chemical language-based approaches for protein-ligand binding affinity prediction, starting with the SMILES representation of the compounds to represent the ligands, and then the amino acid sequence of the proteins to represent the proteins, and then combining them in this XGBoost sort of architecture, and then predicting the affinity score. This is one of the methodologies that has been proposed recently, and ChemBoost does achieve high performance in comparison to benchmark and also state-of-the-art, which at that time that we presented actually was our own other model called DeepDTA. And this is very nice, right, to achieve high performance in comparison to benchmark, but predictions for novel biomolecules is a challenge. What do I mean by this? So what if in your test set you have some compound or you have some protein that you haven't seen before in your training set, right? The machine learning model never saw an example of that protein or of that compound. So it's very hard for it to make predictions about those proteins or compounds. And we showed that, and this has been shown by others as well, that the warm setting, where the training set contains examples for the test set, has high performance, but cold ligand, cold protein, or cold, where the model hasn't seen either the ligand nor the protein before, the error or the concordance index in this case, the performance is very unsatisfactory. Okay, so if this is a challenge, then let's try to overcome it. And we recently proposed this approach that we call debiased DTA to improve the generalizability of drug target affinity prediction models. And here was the problem. And this is a common problem, right? If or when dataset biases are outstanding, models can learn these patterns. In fact, I mean, you can also think of it as memorization, right? Some of these patterns are so repetitive because you've sampled only a small region of this knowledge space. A machine learning model just makes a prediction about some biased patterns or some spurious patterns, spurious associations. This is also a common problem in patient data, actually, where patient data collection is biased for usually white males of 35 to 55 years of age. And many regions of this patient data collection space are, you don't have access to that because of data collection practices. Okay, so, but let's focus on drug target affinity prediction. And if and when data set biases are outstanding, models can learn or memorize these patterns. But let me flip this backward. Maybe we can think of it as, well, what are the causal or invariant relationships that I can build within the data under the assumption that such relationships are robust across different distributions. So I know that there will be some biases that the models use to memorize. What if I looked at the underlying, let's say, landscape to find those causal and invariant relationships? What I would need to do is to find out what the biases are, take them out, and what remains will be the invariant relationships for robust affinity prediction. So we proposed a two-step approach, where in the initial step we use a weak learner to identify these biases, and we call this we calculate an importance coefficient, which will be higher for more informative samples or for samples that have more uniqueness, right? So the weak learner learns the biases, and then we have a second step where the importance coefficients are used to guide the strong learner training. So in this two-step process, the first step learns the biases are taken out, let's say, fished out, using this importance coefficient idea, and the strong learner training is guided by the importance coefficient. And we saw that the debiasing improves prediction performance for different types of models, not just for deep DTA, but also others, in the warm setting, as well as you see the biasing performance. The debiasing improves performance, but also in the cold ligand, cold protein, and cold both setting. It was especially valuable for us to see the improvement in the cold protein setting, which is a challenge in protein-drug interaction space. Representing proteins is not so straightforward. So I have talked to you about these different types of approaches that we have used to address this problem of data scarcity. And we recently also published a paper on this topic, a review paper on this topic that we called Labels in a Haystack, Approaches Beyond Supervised Learning in Biomedical Applications. And I already talked to you about some of these approaches, such as active learning, transfer learning. Merve talked about this a little bit also. Few shot, zero shot. We summarized such approaches in this paper that we called Labels in a Haystack. Okay, so the three takeaway messages that I have, data scarcity and imbalance are big challenges for deploying generalizable NLP solutions. And in fact, this focus on more data-driven approaches, meaning, how can I improve my data collection? How can I make sure that I'm aware of the biases in my data collection, are becoming more and more important. Approaches beyond supervised learning can unlock the potential of machine learning by helping find these needles in a haystack and by making more efficient use of the available labels. And then collaboration, open source, and open science can help propel a data science team. So you see, I started with this use case from an industrial setting, and I layered on the science. And in fact, as I mentioned in the chat as well, Hugging Face is one of the big, let's say, inspirations for us as well. And here, I tried to show you how actually this focusing on the science helped us build ever stronger use cases with higher performance within the company as well. Okay, so I'd like to thank a few people. We are a very global team of data scientists sitting across the globe. As I mentioned to you, we serve the different affiliates and multilinguality, for example, I mentioned to you. The NLP engine team, I'd be remiss to not thank them. So this is our internal NLP capability that I have talked about in other settings. I'm happy to talk about that more if anybody has questions. And of course, I would like to thank Arzucan and our students. All of this work started, I don't know, maybe 10 years ago, when we started collaborating with Arzucan, and Hakime was our first PhD student, and our students have now, all of these students have now gone on to do their PhDs in different, or postdocs in different universities. So I'd like to thank them as well for helping us focus on the scientific aspects of NLP. And this continues to this day as well. Okay, so thank you very much once again to the organizers, and thanks for listening.
Thank you, Elif, for a fantastic talk. In my subjective view, this is like, it aligns so much with my research interests. I was like, yes, active learning, yes, beyond supervised learning. So we should find a way to collaborate. I don't know. It's so.
I'm happy to do that, of course. Yeah.
So, any questions? Okay, so there's one question. So someone is asking for the cold protein problems, like for the cold data problems, do you use GANs?
Right, actually we do. We have another PhD student that I didn't show in the picture that has been using GANs, and actually this is an area of active research. Maybe you can listen to some of Yashua Benjo's talks where he uses exactly this idea. This was very satisfying actually to hear of how can we make predictions about the next experiment to do using some of these ideas of debiasing, basically. So how can we, so you have this knowledge space and you have collected information from the different regions of this knowledge space, but now you want to run your next experiment informed by whatever you collected, right? So it's not enough just to say, oh, let me sample this space, because that space is not like a 2D space that I'm showing you, obviously. So how can we make predictions for the next experiment is actually powered by this GANs idea. So you can check out GFlowNets and such papers and Yashua Benjo's talks. Yeah.
I'll ask a quick question and then we will invite our next speaker. So some of the data that you probably use are like, you cannot share it, right? So are things like federated learning or privacy preserving machine learning, these are things that you have been working on in the company? Or?
Absolutely, absolutely. So I only talked about NLP because I was able to
focus.
This is a big focus, both because of its, so we have a lot of, at the end of the day, the medical profession is actually quite conversational, right? Doctors and patients have conversations. So there are a lot of use cases focusing on NLP, but at the same time, we do, I mean, there are at least 3-4 talks related to real-world data analysis.
Okay.
And also, of course, these privacy preserving methodologies like synthetic data generation or federated learning. So these are big focus areas for our team and for the company in general, because of these challenges with data collection and data access. Absolutely, yeah.
That's great. Thank you so much.
My pleasure.
Once again, it's a delight to hear you talk.
Pleasure.
We will now we welcome Hatice Ülke Osman Beyoğlu. So Hatice is an assistant professor of the Biomedical Informatics Department and UPMC Hillman Cancer Center at the University of Pittsburgh Medical School. Her research focuses on developing the data-driven computational approaches to understand disease mechanisms in order to assist in the development of personalizing anti-cancer treatments. Previously, Dr. Osman Beyoğlu was a postdoctoral researcher at the prestigious Memorial Sloan Kettering Cancer Center He obtained her PhD in biomedical informatics from University of Pittsburgh, holds a MS degree in electrical and computer engineering from Carnegie Mellon University, where we actually met first. And she also holds an MS in bioengineering from University of Pittsburgh, and she has her BS in computer engineering from Northeastern University. So she's a recipient of the NIH and NCI Pathway to Independence Award, Memorial Sloan Kettering Postdoctoral Research Award, and the Innovation in Cancer Informatics Award. So we are going to hear a very exciting talk in the intersection of biology and machine learning. Welcome, Hatice. Thank you.
Thank you so much, Öznur, for inviting and for your nice introduction. Let me share my screen. Today, I'm going to talk about interpretable deep learning and cancer genomics. More specifically, the talk is going to be about how we can model the impact of mutations on transcriptional programs for the purpose of precision medicine. First, I would like to give a brief introduction to cancer biology and cancer genomics to motivate the application that I'm going to talk today. Signaling pathways converge on the nucleus, modulate the activity of transcription factors, which cause up and down regulation of their target genes. You can think transcription factors as a switch. It can repress or induce their target gene expression. And these gene expression programs define the phenotype of a cell. In cancer, mutations, copy number aberrations, epigenetic modifications deregulate signaling pathways and change the gene expression programs. And this change of the gene expression programs form the aberrant phenotype of a cell, such as excessive cell proliferation. The targeted therapies are aimed to block this abnormal signaling. So these drugs target the cancer cells compared to chemotherapeutic agents which target all the cells, including normal cells. But as you can see from this cartoon example, cancer biology is very complex. There are multiple edges, there can be different paths in this graph. So one main question is, how can we assess which pathway in a tumor are aberrant in order to make the therapeutic choices? This is a very critical question for precision medicine. Precision medicine is very challenging. Currently, we don't have targetable drugs for all, somatic alterations. There is around 250 clinically actionable genes. By clinically actionable genes, I mean we have drugs to target. Also, not all tumors carry targetable mutations, and sometimes very frequent mutations occur across multiple cancer types. We don't have drugs to target. And also, even we have the drugs to target, most of the patients are not responding to single agent therapy. So because of this, understanding the biology is important. Understanding the interaction between cell signaling and transcription programs at a system and molecular level is critical for designing effective therapies. With the advent of high throughput sequencing, we have a readout of the cells in these different layers. We have genomic data where we can measure whether a patient has a particular mutation. We have epigenomic data. We have transcriptomic data in both model organisms as well as from the patients. One main challenge is generally biological data is very noisy and high dimensional. So how can we capture biological insight from these high dimensional heterogeneous multimodal data sources? One way to do is machine learning. Machine learning can help us to extract important biological signals. Today, I'm going to talk about one main application from our work, how using interpretable deep learning for pan-cancer modeling of these regulatory programs. So motivation behind this study is, same mutation can occur across multiple cancer types. And if we understand its impact, these can inform like needs. For example, if you think about there is a rare cancer where we don't have enough data, in terms of the computational point of view, extensive training data from a more common tumor types can compensate for smaller sample sizes in like similar and rare cancers. So this is our motivation today. Our goal is integrating somatic alteration data, epigenomic data, ATAC-seq data, and transcriptomic data for gene expression RNA-seq data, and to model the impact of mutations in a pan-cancer manner, and asking whether their impact is similar or different across different cancer types. By integrating this high-dimensional data and summarizing those in terms of this predicting patient-specific transcription factors, we are making this high-dimensional data is more interpretable. Let me talk like more details about our approach. Effect of somatic alterations, as I mentioned, on gene expression programs are not equal. And somatic alterations can have context-specific impact. For example, impact of activating mutation in a PIK3CA gene, where we have drugs to target, may be different in different cancer types. Actually, we are seeing this in the clinical trials as well. For example, not all patients with activating PIK3CA mutations is responding these inhibitors of this particular gene. So this relationship is like not linear, and we are going to use attention mechanism to model this nonlinear effects. So what is the attention mechanism? This is a very currently widely used deep learning method to assign importance weight to input features. It is widely used in computer vision and natural language processing. For example, I'm here showing you one example from the computer vision. Self-attention mechanism assign higher weight to features predictive of the label of the image. So this, by this way, if we use the self-attention mechanism, it is giving more interpretability to the model. And in some instances, some applications, even self-attention mechanism is improving model performance. And this is kind of an overview of approach. So our method is called CITRUS, chromatin-informed inference of transcription regulators using self-attention mechanism. We are using, in the supervised approach, we are using somatic alterations as an input. Then by using self-attention mechanism, we are assigning importance weight to each somatic alteration if they are predictive to more related to this gene expression programs like alpha-1 to alpha. Then there is this full connected layer, and this transcription factor layer is here where we are retrieving the transcription factor activities. Then we are using this sparse prior for transcription factor and potential target genes based on the epigenetic data, where I'm going to talk in the next slide. And the final layer is this expression layer. So when we model this flow of information, we are not only learning patient-specific transcription factor activities by retrieving from this layer, but also we are giving this important weights to somatic alterations which help us to predict the gene expression. So this work is done by Yifeng Toa from Russell Schwartz group and Sojun Ma from my group. So I also want to mention like how we are using epigenomic data to construct this gene transcription factor prior matrix. Here we are using ATAC-seq data. This is a very novel technology where we can measure open chromatin region genome-wide. And then using a motif analysis, we can get a prediction of like which transcription factors are binding these open chromatin regions and potential to regulate these genes. Here we are using Cancer Genome Atlas project ATAC-seq data, we form a common atlas, and then we form this gene transcription factor cancer-specific priors. Because transcription factors, when they are dysregulated in cancer, they can regulate different genes than the normal sense. So the incorporating this informative prior is important for our approach. So to demonstrate the effectiveness of this approach, we use the RNA-seq copy number variation mutation alteration data from the Cancer Genome Atlas project. We also use ATAC-seq data for the subset of the patients which is available. So our data sets like equal to like around like 5,000 tumors. As I mentioned, this is a like supervised framework. We are trying to predict the gene expression from somatic alterations and these gene transcription factor priors. The first thing we ask is how well we do. And we compare our approach to bilinear regression approach, where we predict the gene expression from somatic alterations and gene transcription factor relationships. And in this figure, I'm showing you the performance on health data set, the correlation between the gene expression as well as actual predicted gene expression. Here in the y-axis is showing the Spearman correlation. You can see that for different cancer types, citrus is performing well, and we see the improvement by using this modeling these non-linear features using the deep learning approach. Now let's look at more closer look like what we are learning when we do this modeling. As I mentioned, this self-attention mechanism is assigning important ways to input features which are more predicted outcome or output, in this case gene expression. In this scatter plot, I'm showing you the pan-cancer view. Every dot represents one gene. X-axis is the attention weight, y-axis is the attention weight, and x-axis is the frequency of that mutate that gene. You can see that there's a correlation between the attention weight and frequency. For example, highly altered genes such as TP53 and PIK3CA are getting like high attention weight. And also there are other genes which are not that highly frequent, but still getting high attention weight. So these are more important for regulating the gene expression in cancer. And when we look at, for example, breast cancer example here, again, we are seeing same mutation, TP53 mutation getting high attention weight, but also there is like less frequent mutation KM2DC, which is a metal transferase, and which is recently discovered that like it is also very important regulator for estrogen receptor, which is a driver for breast cancer. Another output of our approach is inferring the patient-specific transcription factor activities. You can think about this making it more biologically inspired, like dimensional retraction, by integrating these different data sources. In this figure, I'm showing you clustering of the patients according to this inferred transcription factor activities from our model. Every dot represents one patient, and different colors represent different cancer types. And you can see that patients are mostly clustered according to their cancer type. But we are also seeing that like related cancers, such as like from the same organ, like kidney cancers are clustered together, or same morphology, like squamous cancer, lung squamous cancer, head and neck squamous cancer, cervical cancer are clustering together, like adenocarcinomas are clustering according to their transcription factor activities. As I mentioned, actually our main goal is like modeling the impact of mutations to transcriptional programs to understand their functional role. So here we use this knock-on silico approach to relate mutations to transcription factors, and we just flip its like status, like making it mutant to not mutant, and then apply the citrus again, our approach again, and look at the change in the transcription factor activities. So in this simulation, we are taking everything in the same, but changing one mutation status. Then looking at whether transcription factor activities, which transcription factor activities are decreased or increased. So to make things more clear, let me give one particular example from our analysis with the breast cancer. In this figure, I'm summarizing this knockout experiment results. So rows are the somatic alterations, columns are the transcription factors, size of the dot represent the significance scores from our analysis, and the color represent the mean transcription factor activity differences between mutant and wild type patients. And I'm going to talk about more about this PIK3CA mutation, because like now this PIK3CA activating PIK3CA mutation, there's like drugs to target. It is both using clinical trials. Actually, it is used for treating patients, breast cancer patients, which has PIK3CA mutation. And when we look at this PIK3CA mutation and identify associated transcription factors, we are using reasonable things like, for example, HIF1 alpha, which is already shown that it is associated with PIK3CA mutation. We are also discovering novel associations such as STAT4 and NFAT-C1 involved in immune metabolism pathway. So in this box plot, I'm showing you the difference between patients which carry PIK3CA mutation and wild type patients which doesn't have the PIK3CA mutation. You can see that there is increased activity of STAT4 as well as NFAT-C1. But if you look at the just mRNA level of these genes, you don't see that distinction, because like transcription factors are generally lowly expressed genes, and it is hard to detect their like functional role just by looking their mRNA level. So in order to validate our predictions, we use experimental models as well as patient data where they treat the patients with this PI3K pathway inhibitors. In order to validate what we are doing is like there's a cell line model. This is a breast epithelial normal cell line, but they introduce this PIK3CA mutation. So the only difference between this parental and mutant cell line is PIK3CA mutation status. Then they perform the data that we are getting this study, perform the attack-seq. So we look at this differential chromatin accessibility regions and perform the motif analysis and look at what are the difference between these two cell lines. We also look by using the gene expression data, this transcription factor target gene expression, and we look whether their gene expression is different between parental and mutant cell line, as well as for the mutant cell line, whether expression is changed after blocking this activating mutation using this inhibitor. Also, trial data and look at post the first thing in this differential accessible region between parental and PIK3CA mutant cell line, we are going to see the motifs of the transcription factors we associated with PIK3CA mutation. So I'm in this figure showing the top enriched motifs, and we are seeing the consistent result with our prediction. We are seeing NFAT-C1 motifs, STAT motifs, as well as June motifs. Then we look at this transcription factor target genes expression. So in this table, I'm showing you the top 10 transcription factors associated with PIK3CA mutation in breast cancer from our model, citrus model. And the second column is showing the mRNA level. You can see that in mRNA level, we don't see the distinction between mutant and wild type patients. Just one transcription factor mRNA level is showing the significant distinction. But when we look at the target gene expression, like in this figure, the CDF figure, cumulative distribution figure, I'm showing the result. The red line is the stat for target gene expression, change between mutant and wild type patients, and the blue line is the background genes. You can see that stat for targets are less, showing the significant lower gene expression compared to target. But in cell line models as well as patients, after treating with PLK3 pathway inhibitors, we are seeing the increase in gene expression, which is consistent with our analysis. To sum up, today I show you how can we use like deep learning approach to integrate this high dimensional data sets from cancer patients to understanding the impact of somatic alterations on transcription programs. We utilize self-attention mechanism to capture nonlinear effects of the mutation, as well as we use this ataxic data to construct this sparse transcription factor target gene priors to incorporate to our approach. The structures allow us to quantify the activity of transcription factors, which are very important for regulating gene expression. They are normal, activities occurred by their modus mRNA level expression. And I also show you how we can use cell line models as well as patient data to validate our predictions. So if you are interested in this work, our papers in now bioRxiv, you can check it. Also, we put our code to our lab's GitHub page. Last but not least, I want to acknowledge our team members who conducted this research. Sojun Ma and Drake Parnell from my group, Yifeng Tao is our collaborator from CME, Zinka Lu is our collaborator and research was. And I want to acknowledge my funding. And thank you so much for your attention. I'm happy to take any questions that you might have.
Thank you, Hatice. This was a very interesting talk. I'm looking at the Q&A box. There's no question, but Yüce Begüm Bektaş is thanking you for a very nice talk. I know that her research is also in this area. So I have a small question. So maybe you have shown it, but I might have missed. So this deep learning model that you showed. The biological. I haven't asked yet, but so this model is very interesting in the fact that you get the biological information, the prior information in different components of the model. What I was wondering is like you have these other models based on matrix factorization, right? In your prior work, have you compared them? Like, does deep learning really bring more performance gain compared to those matrix factorization models?
Yes, like actually, like the one slide that I was showing the performance for comparing our bilinear approach. And the advantage of deep learning is like we can scale it. Like, for example, when I was using those methods, I wasn't able to, train these cancer types at the same time. So if we train everything is together, we can also make these comparisons easily.
Maybe I will also ask you a general question, like in our field, since I also work in computational biology, machine learning at the intersection. So we know that biology is rich with data, rich with lots of different machine learning problems, right? Structured sequence data, time series, everything is there. But there is usually a barrier, especially for students who has computer science and engineering background to enter this field. You have your BS in computer science and engineering. So what would you say to them? Like,
It depends on their passion. Like if they are interested in medicine, biology. I was interested in biology. I was fascinated with it. Like for example, if I compare the conferences that I attend, I'm more excited when I attend a cancer-specific conference. And I see like machine learning as a tool. I'm, better at the data science. I didn't want to go and do experimental work also. Then I thought computational biology is a fascinating field. Like I can do biology, I can use these technical skills, like I have the engineering background. So I was fascinated with it. So it depends on their interest. If they want to make impact in the medical field, I think, this is a very exciting area.
Right? Yeah, I agree. Thank you so much. It's very late there. I know you are in San Diego, right? Are you attending RICO?
No, it is like 5 a.m. here.
Okay, yo, but you seem pretty awake. Okay, thank you so much. Hope to see you in Turkey if you come. We will have a break now, a coffee break, and then we will continue with the panel of young data scientists. Özge will be moderating that. See you in 15 minutes.
Hello, everyone. This session about young data scientists. We will start after 1 minute.
Hi.
Okay. Hello.
Hello.
Now we will talking about young data scientists with our panelists. We will talk very successful young leaders in their careers. Firstly, I want to say thank you for the accept invitation. Firstly, please, can you introduce yourself, Begüm?
Hi, I am Begüm. I have been working as a data engineer in Vodafone until the beginning of May. Now I'm working in a different field, trying new things. But I graduated as a electrical electronics engineer. Kind of diverged from that path, so that's it for me.
Çisem?
Hi, my name is Çisem, and I have graduated from Koç University with a double major in computer engineering and electrical electronics engineering in 2019. And I have joined Yapı Kredi Technology as a research and development engineer after graduation. And after Yapı Kredi, I switched to consulting, and I worked as a machine learning engineer in consulting. And lately, I have been working as a machine learning scientist in a startup in Silicon Valley, close to 1 month, I guess. Yeah.
And Sukejna, right?
Sukejna, yeah.
Sukejna, sorry.
No worries. Yeah, no worries. Hi, I'm Sukejna. I was born in Bosnia and Herzegovina, and then I went to Turkey for my undergraduate and graduate studies. I graduated from Boğaziçi University in 2018 as a double major of molecular biology and genetics and chemistry. I then did my master's in computer science and engineering at Koç University and graduated in 2020. And after my graduation, I actually started working at HSBC as a data scientist. And this year I have been promoted to senior data science position. So I'm still in that position.
Thank you. First question, how did your data science or technology career journey? Begüm.
Well, I was in a new graduate program in Vodafone, which help you to discover what you want to do with your career in the long run. So they put us in different teams in data science. So it helped me to discover what I want to do, how I need to move forward with it. So it kind of started with it, but previously I was learning about more general concepts in data to help me jumpstart with it. It was more like that.
Thank you.
So yeah, I kind of suggest people to apply to programs like that to learn more about data science in general.
Okay. Chisam?
Yeah, so my interest in machine learning has actually started when I was studying. So I was lucky enough to take undergraduate courses when I was studying, but like it wasn't enough for me because I really interested in machine learning engineering. I have attended master courses in machine learning, like deep learning, but I haven't taken credits because I haven't had the courage at the time. So, but these kind of courses gave me enough interest to complete my dissertation projects. I had two of them in natural language processing, and these projects, I guess, lead me to a career in this field, I would say.
Okay. Sukaina?
Yeah, so my story was not really directly into engineering. So I was more into life sciences and natural sciences when I first started my undergraduate degree. However, as time progressed, I realized that actually there are a lot of available biological data sets that are having already data which we are trying to get in labs. So I actually started getting interest in bioinformatics and biostatistics at that point of time. So I took numerous courses, including machine learning as well during my undergraduate, next to my degree actually. And then in my graduate studies, I actually understood that applications of machine learning in natural sciences was what I was interested in. So my graduate studies were mostly around that area. And later on, as I graduated, I wasn't actually planning to work in financial area, but the opportunity that I got here in London was quite interesting to me, and it was mostly like research and development oriented. So I decided to accept, and yeah, that's how it progressed.
Okay. What software program do you use in your job about data or data science?
So I can start again, I guess. We mainly use SQL or PLSQL in the area we were working in. It was more in data warehouse technologies and stuff. In addition to that, we use a lot of Oracle technologies like Oracle Data Integrator or something called Informatica. It's more like an ETL tool. So I'm more in that side of the data field, not like machine learning and stuff, but more like modeling data, getting big data and stuff like that. So we mostly use these tools.
So I can continue, I guess.
Yeah.
And I'm like more in the modeling part, maybe, but I am still, I still have to deal with data most of my time, I guess. And there are some tools that I have always used, like Python. It's like main language in machine learning, and scikit-learn. It has all the models and evaluating metrics, and like keras and TensorFlows made it easy to build a model from scratch. But it's like the tools are changing according to where you work. So, for example, when I was working in Yapı Kredi, I was using like more SQL because it's a big corporate company and there are database like everywhere. I need to gather data from every one of them, and I need to process. Nobody like hands you a data set. So here, this is your data. Go create a model. So I need to go clean it, work on it. But like when I switched to the consulting company, it was more like creating proof of concepts for our customers, because you need to persuade the customer that you can do things, you can create a valuable solution for them. So I used a lot of Hugging Face models because they are made quite easy to create a POC just 1 to 2 business days, I would say. So I just create a model and show our customers to persuade them that you like, here you can see this can be a valuable solution for you. And after here in Turing that I am currently working, it's a startup that matches developers to this, and I'm working on the ranking problem, ranking developers. And here since it's a startup, there like the data is kind of messy. It's not like fixed process. So I need to work on a lot of visualization because I need to show people that here you are doing something wrong and here you are doing something great, just keep it up. So I would say I am leaning towards the visualization libraries such as Matplotlib, Seaboard, etc. And yeah, that's all I got.
Okay. Are you using SQL or R or any data visualization tool?
SQL is
like
part
Power
of my
BI?
life. No, I have never used Power BI, to be honest, but SQL is a big part of my life. And other than that, Python libraries.
Python is very important for the machine learning system, right?
Yeah, definitely. It's inevitable. It's a crucial part of it.
Skrina?
Yeah, so to be honest, I would first want to say to people listening that please do not limit yourselves to certain languages or tools, because these change as time progresses, and you don't want to be limited in just one area. So I would definitely suggest them first, if they are planning to get into data science, especially in modeling part, to first get a very good foundation of maths and stats, and then maybe progress into machine learning algorithms just afterwards. So first get your mathematics very well and then get into algorithms. And I would want to say that, yeah, like definitely having one programming language as proficient is very important. You don't need to show like 10 programming languages, but just be proficient in one. And currently, like if we look into trends, I would say that Python is the most widely used language in industry, especially in non-academic parts. So definitely Python is something that I would recommend. Also, query languages, extremely important, because no matter how high your position is or how modeling oriented you are, definitely you will have to query your data either from cloud or from your local databases. So definitely one query language is recommended. Currently, I believe SQL is most widely used, and at the same time, the languages that are used at cloud are quite similar to SQL. So I would definitely suggest learning SQL. And one more thing is, at the same time, libraries change as well. Like libraries progress, they evolve. For example, we were all into pandas, and now like there's new things coming that have better speed, etc. So I would definitely suggest, yeah, knowing libraries is good, but knowing the foundation is much more important. Once you enter the company, whichever languages, whichever technologies they are using, they will teach you anyway. Like you will have to learn. So they will, in the interviews, they will be mostly asking you about foundations. So that's something that I wanted to say. And also visualization, as Chisam mentioned. So definitely it's not only about the results. So when you show numbers, people might not understand, but when you show pictures, most of the stakeholders will be on board. So definitely visualization tools, not to skip. But as I mentioned, not restricting yourself on specific ones. So yeah, just getting the concepts is, I think, the most important.
Okay. I'm always talking with the young data scientists. They are always saying what is important for the data science career. I'm always say statistic is very important for the data science. What do you think about this? Statistic, is it important for the data science?
Definitely. Statistics, I wouldn't just limit it to statistics. I would just say generally like a package of math, like all calculus, linear algebra, and probability and statistics are, I would say, important, because once you get once business approaches you, they approach you with certain objectives that they want to achieve, and usually these objectives are just sentences that they want to see. So it's up to you, to sit down and model what they have requested. You need to model it into mathematical language in order to be able to run your models and present. So first, definitely statistics, extremely important, like modeling your data, modeling the probability underlying the data, very, very important. At the same time, like, you are not always able to use the loss functions, etc., which are available in the packages. Sometimes, according to your business requirements, you really need to sit down and create your own custom loss function, and this really requires extensive, linear algebra language and at the same time statistics. Yeah, but generally mathematical package is, I would say, a must, especially in the modeling part.
What do you think also, Chisam and Begüm, about software tools or statistics for the data science?
I would definitely agree with Skena. It's a crucial part of machine learning, the math. But I also think that if you want to just go into this field, you can start by maybe the fun part, just go play with models, and then maybe work on your foundations, your fundamentals. It's another path. I would definitely agree with Skena. It's really important, but just if another path exists, I would say that.
I agree with both, because in the end, you need to know these things. You need to understand what you are doing, and you need, in order to show people what they want, you need to understand it first, and you need to know how to show them what they want. So it's mathematics is so important in all engineering fields, in all software fields, but especially in here.
Okay, thank you. And what do you think about the future of data science or just data? Begüm.
It's data has become such an important part of our lives. It's never gonna go down. It's always, you need to improve how you process data, how you use data again and again and again, and it's just gonna grow all the time. So it has a very bright future in general. So since I'm a newbie in this field, I can't imagine how things might go, as well as these other two very successful women in here. But it's never going to go down. That's all I can say.
Yeah, you worked very big telecommunication company, and also I'm thinking also important data storytelling, right? For the what we are doing with the data for our company.
Yeah, you need to, all companies want to grow their companies more and more, and they want new features in their company. So we're not just a telecommunication company anymore. They do different things like e-commerce and stuff like that. So in order to grow in another field, you need data. You need to know how people react to these. You need to see the new trends, how well your customers are getting along with this new feature. So it's very important to stay relevant in your field and also growing into.
Okay. Chisam, what do you think about the future of data science data?
Okay, so when I graduated and I was looking for opportunities, like there was really few of them about machine learning in the time, and it was like 2019. But here now, and I see like the opportunity, numbers of opportunities are quite increasing, and this means that the companies are getting more aware of machine learning and its power and the data, of course. So I don't think it's going back. It's really going forward. The data science will be the default of our lives, a crucial of our lives. And yeah, I guess maybe I can tell you that like what I have seen in consulting, I have connected with many clients, and there are like two types of clients. One type of client is really don't understand machine learning and doesn't trust. But I need to persuade them machine learning is a science, is a scientific thing, and it can give you results. And other type of customers, I think machine learning is magic. It can do anything. It can tell you what to do, what to perform next. And I think in the coming years, people will come to a level which is logical. They are going to understand machine learning. Now, if you go and ask a random person about machine learning, they don't know. They like even if HRs don't know about machine learning, they ask quite weird questions about it. So in my opinion, it's going to be the default of our lives, and more people will know about that.
Okay, Sukaina, what do you think about the future of data science?
I definitely think that it's going upwards. Like we can see like pretty much exponential growth in the number of positions, and at the same time in the application areas that are being present more and more. However, I do think that as data is growing, at the same time, challenges will come as well. So I think the data is becoming more and more, like we call it like dirty data. It's like you have a lot of bots and a lot of data that you cannot really use if you want to model properly. So there is a challenge of getting correct and useful data, extracting it from the whole sea of available data online. So I think that's one of the challenges. And at the same time, like the ethical concern is there, especially, for example, when working in financial area. Like ethical concern is one of the biggest challenges that we get questioned even now, and I think in future it will be even more. So is there a bias towards certain genders? Is there a bias towards certain age groups, etc.? So the challenge of explaining these is definitely coming. So I think as data is growing, as both Begum and Chisam said, it is definitely growing, and I don't think it will go because two major things for data is computation power and the size of data. So both of these are currently very easily available. So I would say it's not going away, but definitely we just need to make sure that as we are growing in this area, the challenges are also being taken proper care as early as possible. Yeah, that's my comment.
Sukaina, are you living in London now, right?
Yes.
Also in London, data science career, is it important?
Definitely. Here, like pretty much even small companies do have data scientists. So I would say like, I think even in Turkey currently, like there is like a momentum towards, as Begum mentioned, like more and more companies are being aware of it. But in London, for example, it's been here for a while. So like I can see people that have been a data scientist for 10 years, here. So it's been here for a while. And as I mentioned, like nearly every area that you can think of in industry is applying some kind of machine learning. So definitely it's a great opportunity, like especially UK and maybe London area and Edinburgh are one of the hubs in Europe, and I would suggest people listening, if they are interested, definitely applying. And market is so hot, like even people who have position, you don't need to apply, you are being approached by 10 people every day. So definitely I would suggest researching the market here. It's quite hot.
Okay. Last question. Do you have any career suggestion to our listeners? Skena.
Should I start? Okay. So one thing is, I think what we call SME in industry, like subject matter expertise. Get to know your project. Like once you enter, like first maybe, before entering, first maybe you should speak about entering the job. So before speaking about progressing the career. So in order to get into some data science position, I would definitely suggest, have your Python, very proficient and ready, have your SQL in, and be aware of the concepts and apply as much as possible. Like I think the interviewing process itself is teaching a lot. So don't be afraid of applying, apply. Maybe first 100 positions won't be your position, but 101st one will be. And I'm sure that you will learn much more from the interviews themselves than you have been learning through your projects and just theoretical preparations. So definitely enter the interviews as much as possible, and don't be afraid to apply abroad as well. I wasn't thinking, for example, that I would get into London the moment I graduate, and it was so, the companies are not afraid of getting sponsorship for you. So don't be afraid of, applying abroad as well. So once you are in the job, for progressing your career, for example, I was a data scientist at the beginning of 2020, and I got promoted to senior data scientist in 2021. And currently I'm like the youngest senior data scientist in the whole corporate. So it's quite, quick progress. And I think the most important things that helped to me were definitely subject matter expertise. I was sitting down and, learning what project is doing, not just the data science and techniques, but generally what the project is about, what are the objectives, communicating these to stakeholders. And definitely, I think I would suggest once in your position, get a buddy. We have that concept in HSBC. We call it like mentor buddy. Get one of the seniors around you and have them, 20 or 30 minutes every week. Just have a short call, explain them what you are doing and seek their advice, both in career progression and on what you are doing. So I think these two things were the most important things that helped me in my career jump. Yeah.
Okay, thank you.
Maybe I can go next.
Yeah.
So I think it might be a little early for me to give career advice, but I can tell a little about like what I have learned in my 3-year career. Mostly, the first thing I would say would be that you should not be afraid of trying new things, because it's a really fast progressive area. So if you are trying to solve every problem with logistic regression, there will be some time that you cannot solve it with logistic regression. It's going to be too far. So it's really important to get out your comfort zone, get out to like trying different methods, models every time that you can learn new things, firstly. And another thing that was shocking news for me after academia, I have seen that in the industry, it isn't important to get the extra 1% increase in accuracy. Nobody wants to spend time working on like 2 weeks, working on the just 1% accuracy increase. So it's not like academia in that terms. And another thing is different from academia in the industry is that the data is really messy. It is not like any data set I have ever seen. It's like most of the time it's not usable. You need to decide on that. And this decision process isn't something that you have learned before. So I will say when you are going at like when you are following a blog post, which is a like fixed data sets going around, you need to spend time on preparing that, cleaning that, even if it isn't like required at the time. It's a really essential skill from my perspective, I would say. Yeah, that's all from me.
Thank you.
What I think helped me the most is to see different fields, different fields of data science being used in Vodafone, and talking to people who are working on different fields, like big data is a different field, or there are machine learning engineers, AI engineers, there are data warehouse data engineers. So talking with them, what they're doing, what they need to know to do their jobs, what does their day look like, day-to-day tasks look like, really helped me to understand what I want to do, what I need to learn more to work on a field that I want. And another thing I see that's very useful is attending hackathons or contests and stuff. Contests from Kaggle maybe. So we have a Technofest in Turkey that you can join, for instance. They help you to get hands-on experience and see how the real process really looks like, other than what you learn at school. So I think these two are really important in addition to having the technical knowledge.
Begüm, did you select? Do you graduate from Upschool, right?
Yes.
Where they can learn data science skills? Are you using Udemy or Upschool, DataCamp, or Kaggle?
The bootcamp I joined in Upschool is very different than data fields. So it was about mobile development. But Udemy is one thing that helps. So when you're not, at least when I'm not with other people, doing things with other people, it kind of lowers my motivation. So it's more useful for me to join, for instance, hackathons and maybe projects with friends at school. These are more motivating for me. That's why talking to people who are working in this field is also very important for me to know where I'm going, where I should do. Maybe having a mentor who is maybe a senior in a company is very useful when you're just beginning and you don't know what to do. It's such a big field. There are many tools, and they can help you with figuring out the road you want to go. And it can change in your career too also, I guess. But I just started, so I can't say anything about that now.
I'm thinking mentorship program is very important for the careers. Upschool, very great company for the data science skill. Sukeyna and Sam, where can they learn data science skill? Are you using Udemy, DataCamp, Kaggle?
I'm not a very huge user of Udemy, to be honest. I'm more a fan of Coursera maybe, and generally I think being interested in one area, maybe just taking one machine learning course should be pretty much enough to get you to know which areas are available. Once you are aware of the areas, I would more suggest like picking one project and working on it. For example, you are aware that there are, like, let's say, computer vision, NLP, time series, or machine learning on networks, or like what's really booming lately, reinforcement learning, for example. Like once you decide which area really catches your attention the most, afterwards, I think picking a project in that area and working on it directly. You can pick a project from Kaggle in the area that you like, and then really Google while you are working. Literally, going through Medium. Medium is excellent for readings. Then I don't know, Machine Learning Mastery is a great web page as well. Just learning, Googling, what you need to do as a next step in your project would bring, I think, the most benefit, because once you're hands-on and really working on the project, it catches your attention. But when you are, listening long course without any, application or without any product that you will be delivering in the end, I think it loses attention of the viewer, and it's not as beneficial as when you are really working on something. And when you work on a project, you're literally thinking of it during night, during day, like, what would I do there, or what would I do there? And you're Googling, like how to approach this problem, or, in feature selection, I have this problem, how do I approach it? Or in, let's say, modeling, I'm optimizing, but, my metric is wrong. How to select a metric. For example, when you have a question to answer, it's much better to learn than when you are, learning from all available questions and all available theoretical knowledge. So I would definitely suggest first taking one maybe short course, learning which areas are there, and then picking the area of your interest and doing a project in it. Also, projects look amazing on your CVs, and you can share your code on Git, and you can present your code in Kaggle as well, and the companies will be much more willing to take you in once they know that you really can apply the knowledge into real projects. So that's something I would suggest as a path.
Thank you. And Sam, what do you think about online courses for the data science careers?
Yeah, I'm with Sukena in this one. I am not really a fan of online courses. Like they are too long, and if you don't do anything, as Sukena said, you won't gain anything. So it's really, you really need motivation to keep up with it. Maybe it's because I have taken courses when I was the undergraduate student, so I had my fundamentals. And after that, my way is to, like, if I want to learn more about graph neural networks, I just go find a course, online course in Coursera, Udemy, whatever, and I took the syllabus. What should I learn? Like, what is the topics? So I just go Google it, go find a blog post about it. And I think Twitter is a great place to follow scientists. Like they share lots of things, and machine learning area is quite hard to keep up with. So you need to just get little bites of information and just know, oh, it's something, and I don't have any interest in it. But oh, there is new thing and it looks very interesting. So maybe I should go research a little bit about it. So this is actually what I am doing currently. So like there are some websites such as Paper Digest, and it gathers some papers published recently, and just create a page containing first paragraphs, abstracts from them. So these kind of tools are very useful, in my opinion, to keep up with the machine learning in general. But another important skill is reading papers. Reading scientific papers is a must in this area, in my opinion. So if you don't have this, because I haven't had the skills when I was a student, it will take me 2 days to read a paper line by line. But now skimming a paper would be at most 1 hour job for you, and you can learn many things from papers because it's where machine learning is cooked. So I will say don't be afraid of papers and going through Google at all.
Thank you. We have 2 questions. How would you learn data science if you had to start over? What do you recommend to minimize effort or maximize outcome?
Maybe I can say a few things about that. I would definitely take a fundamentals course, like covering machine learning basics, and then working more on projects, because I mostly read about machine learning rather than doing it in my first months, I would say. And then I realized working on a project would be much better So picking a project and working on it, like Sukena said, would be a great way to start, in my opinion.
Thank you. Do you think focusing on specific subject in data science, such as time series prediction, helps to get a job easier?
I can take this one.
Yeah.
Time series is a quite specific topic. If you are planning to get into financial area, for example, and predicting risk, then it might help. But I wouldn't suggest focusing directly on time series because it's just too specific, I would say. Maybe focusing on deep learning in general and picking projects from, for example, deep learning, and then maybe you can apply deep learning onto, using time series onto some, type of project might be good. But I wouldn't really suggest that focusing on one specific area would get you the job. I would say knowing fundamentals of machine learning, like especially classical algorithms like classification or unsupervised learning, or like widely known classical machine learning algorithms, how we call them, are much more useful in interviews. But if you are like interviewing for a specific role in area where time series are extremely important, like I mentioned, risk predictions or stock predictions, then yeah, it would be helpful. But again, next to time series, they would still ask you general concepts. So I would definitely say knowing general concepts is more important, but also at the same time showing few projects on your CV would get you the job, I think. So getting general concepts, knowing them, and having one or two projects of your interest on the CV would be beneficial. One of them can be time series, for example, but definitely one of them should be something more general, some kind of maybe classification problem or some NLP algorithm applied, LSTM, etc. Like some kind of more widely used algorithms might be better on the CV, because even if the company is, for example, predicting risk, like my current position is predicting risk, it's a dynamic risk prediction, but even if they do require you to know like time series, they would say, okay, if you know general concepts, it's fine. Once you get into job, anyway, you will get to learn like very deep concepts. So general knowledge is something that is mostly asked on interviews. I don't know, I'm entering interviews for like Singapore, Mexico, Poland, UK locations for data scientists. And generally we ask general concepts. So it's a plus, when a candidate is knowing one specific area, but definitely not a requirement. I do want to add that if you have certification in some of the cloud technologies, for example, GCP certification or AWS certification, those can be helpful because most of the data scientists would know concepts, but not many will have like experience with cloud because it's usually expensive to get it. So maybe that kind of certification can be a plus when we are deciding, whom to take in. So, but I wouldn't suggest, concentrating on one specific area, just that area without knowing general concepts.
Thank you. I'm thinking that was an inspirational session. I want to say again, thank you for the accept to invitation, Begüm, Çisem, and Keyna. Thank you again, also our participants. Thank you. Nice to meet you all again, Sukeyna, Çisem, and Begüm.
Thank you for having us.
Thank you.
We are continue closing remarks with our team.
Thank you so much for a very interesting session.
You're welcome.
So I would like to have few words before we close. So I want to thank our support host, Sabancı University and Verin, for technical support, and also our communication supporters, various student branches. Also, these are our volunteers, and if you guys can turn on your videos if you are here, that would be great, so that people can see you as well. Maybe I'll stop screen sharing. Okay, so this event was made possible by a very talented set of volunteers. We have a few missing people. Osman is not here, I think, and Buse couldn't make it at the end. During the day she was here, but so we want to thank you personally. It was really fun to work with you. And Buse, do you want to say a few words?
Okay. First of all, I would like to thank all the amazing speakers, participants, and of course our ambassadors on behalf of my volunteer friends. And after the event, we will send you a survey by email, which will take probably like less than 3 minutes. And it will be great to get your feedback in order to make this event better in the following years. So thank you and hope to see you again next year.
Yeah, thank you so much.
Thank you.
End of our Aslan made it.
I just made it on time. You made it on time.
We were just closing and we just said thank you.